Discovery Houston, that S-76 comm mission message is a camera over temp.
Roger, Lacey, we turned them off to rest them.
Okay, thanks, Mike.
This is Mission Control. In about 12 minutes at mission elapsed time 5 hours and 30 minutes, or 5 hours and 35 minutes, the orbiter will begin to maneuver to its deploy attitude. The official deploy countdown is scheduled to start at about 5:45 mission elapsed time. So far, all of the checkouts of the payload and its upper stage have gone very well, and flight controllers have been pleased with the data they've been getting. So far, the direct checks of both the inertial upper stage and the tracking data relay satellite have been good. The checks through the payload interrogator on board the orbiter have been good, and it looks like everything is proceeding very well toward a deploy scheduled at mission elapsed time of 6 hours and 13 minutes, which is about 53 minutes from now. At the end of this TDRS pass, there will be a mission directors conference, and that conference involves the Sunnyvale flight director and the White Sands flight director, the mission director here at the Johnson Space Center, and the flight director and the payloads officer here in Mission Control. These people all have a pre-deploy meeting on the flight loops to check out on the status of the payload and make sure that everyone is in agreement to go for deploy. At mission elapsed time 5 hours and 20 minutes, this is Mission Control.
Discovery Houston, we are on minute and 20 seconds to TDRS LOS. We will see you at Guam at 5:51.
See you there.
This is Mission Control. We've lost signal with the crew over TDRS. We'll pick up with them again over the Guam ground station in a little over 20 minutes. Over this last TDRS pass, the crew completed another direct check of the tracking data relay satellite, another PI lock-on check with the inertial upper stage. All of the TDRS and IUS checks up to now have been good. We are about 42 minutes away from deploy, which is set for 4:50 p.m. Central Daylight Time, a mission elapsed time of 6 hours and 13 minutes. Coming up in a few moments, there will take place among the payload management community a pre-deploy briefing to poll the team, making sure that everyone is still go for deploy. Over the Guam ground station, we will expect, if everything is still looking good and everyone is go, we'll expect to be giving the crew their go for deploy about 20 minutes before that deploy takes place. While we're LOS, the crew will be maneuvering to the deploy attitude, and the countdown officially begins at about 5:45 mission elapsed time. This is Mission Control.
Discovery Houston, we're with you through Guam for the next 7:45. How do you read?
You're loud with a bad echo, Lacey.
Okay, Discovery, how do you read me now?
That's much better.
Discovery Houston, radio check.
Loud and clear.
Okay, we're reading you 5 squared also. Discovery Houston.
Go ahead.
Discovery, you are go for deploy.
Copy, Houston. Go for deploy.
This is Mission Control. The crew was given their go for deploy, and that's coming up in about 15 minutes at mission elapsed time of 6 hours and 13 minutes, or about 4:50 p.m. Central Time. The voice you heard kind of stepping on the call for go for deploy, we think may have been a playback from a previous recorded tape coming down on another loop.
Houston, Discovery, 30 seconds to tilt table operation.
Roger, Discovery, we copy.
This is Mission Control. The crew will be maneuvering the tilt table up to 50 degrees for the deploy. The deploy will take place over the Hawaii ground station.
Discovery, we're 1 minute to Guam LOS. We'll see you in Hawaii at 6:05.
See you there.
This is Mission Control. We've lost contact with the crew through Guam. We'll pick up in 6 minutes at the Hawaii ground station. During the Hawaii pass, the TDRS tracking data relay satellite will be deployed from the payload bay. Crew is in the process of elevating the tilt table to 50 degrees, which is the deploy attitude. Remaining tasks to be done right before deploy are to release the umbilicals, which feed electrical power to the IUS and TDRS from the orbiter. After those umbilicals are released, each part of that stack will be on its own internal battery power. The TDRS has its own batteries, as does the IUS. We expect the deploy to be at mission elapsed time 6 hours 13 minutes, or that's 4:50 p.m. Central Time. This is Mission Control.
Discovery, Houston, we're with you through Hawaii for the next 8 minutes.
Loud and clear, Houston.
You're 5 squared also, Mike.
And you can take cabin TV at will.
Okay, we copy that. Discovery, we're not going to take TV, so we won't to prevent interference with the PI.
Roger.
This is Mission Control. We won't be seeing the deploy of the payload coming up in about 6 minutes on TV. However, the crew will be recording it on videotape to be played back later. Right now, that's scheduled for 6:18 p.m. Central Time for the playback. We will not take cabin TV on this pass so that we will not interfere with the payload interrogator during the deploy activities. This is Mission Control. We've had confirmation from the Sunnyvale ground station that the tilt table is elevated to the proper attitude for deploy at 50 degrees. This is Mission Control. We're about 3.5 minutes from deploy of the tracking data relay satellite. We'll be expecting a call from the crew giving us a visual confirmation as they watch the satellite and IUS combination leave the payload bay. Mission elapsed time 6 hours and 9 minutes. This is Mission Control. This is Mission Control. We're 45 seconds away from deploy. We're expecting to hear a description from the crew of how the payload looks as it is released from the payload bay.
Good deployment, Houston.
Roger, Discovery.
This is Mission Control. The payload's officer reports that Sunnyvale also confirms good deploy of the inertial upper stage, releasing it from the payload bay. This is Mission Control.
Discovery, Houston with you through TDRS for 53 minutes.
Loud and clear.
You're
5 squared also.
This is Mission Control. The crew will now move on into the post-deploy operations. Mission Specialist Mike Lounge will be lowering the tilt table back down flush into the payload bay of the orbiter and refastening the payload retention latch assemblies that hold that tilt table in place. At about mission elapsed time 6 hours and 30 minutes, about 14 minutes from now, the orbiter will maneuver to the IUS viewing attitude so that the crew can continue to observe the IUS TDRS combination as it drifts away from the orbiter and continue to record that event on videotape.
Houston, Discovery, 30 seconds to tilt table operations.
Roger, Discovery.
This is Mission Control. Flight controllers confirm that Discovery is in the proper attitude for the burn coming up in a little over 2 minutes. That'll maneuver the orbiter to the IUS viewing attitude.
Discovery, Houston.
Go ahead, Houston.
Discovery, we recommend you use Verns for the burn in order to have a tighter deadband.
Roger.
This is Mission Control. The propulsion officer confirms the beginning of the burn. And that it was a normal length and duration. The burn was as it was expected to be, and the shuttle was in the proper attitude. This is Mission Control. In about 10 minutes, we'll be coming up on another almost burn. This is the maneuver to window protect attitude to move the orbiter a safe distance away from the IUS TDRS combination in preparation for that first firing of the SRB, which is scheduled for 5:51 p.m. Central Time. We need to make sure that the orbiter is a safe distance away from the rocket before it fires, so that there won't be any plume impingement, and that is the debris that comes from the rocket engine from the hot gases that are fired. We don't want any of those to inadvertently come in contact with the shuttle or its windows, so we move to an attitude that protects the windows and the orbiter from that any of that debris fallout. We have not heard any verbal confirmation from the crew yet about the tilt table status, if it has been all the way down. However, we expect that it is lowered all the way down into the payload bay. Otherwise, we'd be hearing from the crew that it wasn't. Mission elapsed time 6 hours and 40 minutes. This is Mission Control. This is Mission Control. Flight controllers here in Mission Control are still looking at and studying the problem that developed early in the flight of the flash evaporator system. Although they have not analyzed all the data, they are still considering that the system may have some ice in it due to condensation that froze shortly after launch. To try to help out the flash evaporator system so that it can thaw out a little bit, they've raised the temperatures on the radiators that, while we're on orbit, help to cool the electronics and the systems aboard the shuttle. The flash evaporator system is used primarily during launch and entry, and is not relied upon during on-orbit activities. Due to having the radiators at a higher temperature to help out the flash evaporator system, the cabin temperature has been warmer than usual. It's running about 86, 87 degrees presently, Fahrenheit.
Okay, we copy that.
And the humidity is about 43%. The crew does have the temperature on cabin temperature control on full cool, trying to bring that down a little bit. And the flight control team is looking at ways we may be able to power down some auxiliary equipment in a little while that might help relieve some of the temperatures and relieve and reduce the load on the flash evaporator system and the radiators, so that the radiators can be of more assistance to letting that ice build up, thaw out in the flash evaporator system. The ECOM flight controller, and that stands for the Electrical, Environmental, and Consumables Manager. He's responsible for all the life support systems, the power management, heating and cooling, and so on aboard the orbiter. He and his backroom folks are working on this and analyzing all their data, looking to see what are the best options to make that flash evaporator system work at full capacity. Right now it's only functioning at partial capacity. At mission elapsed time 6 hours and 47 minutes, this is Mission Control.
Discovery, Houston.
Go ahead.
Roger. Give us a status on the tilt table, Mike.
Down and locked.
Okay, thank you. Also, Discovery, since we're running a little warmish cabin, we'd like to recommend you drink a little bit more water, at least 8 ounces per hour.
Copy.
This is Mission Control. The ground controller has reported a data dropout. Communications officer and the ground control officer are working to restore that communications link so that we can continue to receive orbiter data through the tracking data relay satellite. We've got about 10 minutes left in this Teeters Pass. Mike Lounge confirmed a few minutes ago that the tilt table and the airborne support equipment was...
Discovery, Houston, radio check.
Loud and clear, Houston.
You're loud and clear also. We had a momentary drop out of data.
Okay, there's a little static on the loop right now.
This is Mission Control. The report from Mike Lounge was that the tilt table was down and stowed and locked in the payload bay. And we should be maneuvered to our winter protect attitude, waiting for a confirmation of that here any minute. This is Mission Control.
Discovery, Houston, we're still about 8 minutes from the end of the Teeters Pass, but our attitude is not good. We're going to probably have Ratty comm with you until the end of the Teeters Pass, and we'll see you at Guam next. Guam at 7:29.
Okie doke.
Discovery, Houston.
Go ahead, Lacey.
Roger, Dave. We'd like you to check your UHF back on, please, in case you turned it off for that static you were getting earlier. We will have iOS UHF only for about 3 minutes, and our Guam pass will be UHF only also.
Okay, it's been on the whole time. We will not turn the UHF off. We'll just deselect it if we're having problems from the MS ATU, which is what we're using for the speaker mic. But we'll leave the UHF on.
Okay, understand. Discovery, Houston, we're with you through iOS UHF only for the next 7 minutes. Discovery, Houston, we're with you through iOS UHF only for the next 7 minutes.
Okay, let's see you loud and clear.
Discovery, Houston.
Go ahead.
Just a reminder, we'll be looking for the VTR dump in Hawaii.
Okay, we'll try to have it ready.
This is Mission Control. We're about 6 minutes away from the first ignition of the IUS. Its first stage burn is at mission elapsed time 7 hours and 14 minutes and translates into 5:51 p.m. Central Time. That's the first firing of the inertial upper stage that will begin the move into geosynchronous orbit carrying the tracking data relay satellite. A second firing of that inertial upper stage is set for 11:05 p.m. Central Time this evening. We will be receiving word from the Sunnyvale tracking station about that firing after it takes place, and we'll pass that along as soon as we receive it. This is Mission Control.
Discovery, Houston, we're 1 minute to iOS LOS, and we'll see you at Guam UHF only at 7:29.
Go ahead.
This is Mission Control. Our next television will be at the Hawaii ground station on Orbit 6, and it'll be a videotaped playback of the deploy of the tracking data relay satellite. The time for that expected television downlink is at 6:18 p.m. Central Time. Once again, that'll be a playback of the TDRS deploy, and that'll be on Orbit 6 over the Hawaii ground station at 6:18 p.m. Central Time. We've lost signal with the Indian Ocean station with the crew. We'll pick them up again in about 14 minutes over the Guam station for a short pass. On this last orbit, the crew successfully deployed the tracking data relay satellite at mission elapsed time 6 hours 13 minutes, or about 4:50 p.m. Central Time. Sunnyvale ground station confirmed a good deploy. The orbiter Discovery has now been maneuvered a safe distance away to the window protect attitude, and we're at a distance of more than 10 miles away from the IUS TDRS combination now. Flight Director Chuck Shaw officially turned over the rest of the payload mission to the White Sands and Sunnyvale ground stations at mission elapsed time 7 hours and 3 minutes. Once the shuttle is about 10 miles away from the combination, they assume complete control of their payload mission. Coming up, we expect here this evening that the crew will be activating the protein crystal growth experiment. Flight controllers in the mission control room are continuing to look at the various solutions to help along the flash evaporator system to bring it back to full operation. Because we have raised the temperature on the radiators to try to help out the FES, to help it thaw the ice that we suspect has collected there, the cabin temperature has been running a little higher than normal. It's up to around 88 degrees with the humidity about 42%. So the environmental systems engineer and his backroom people are looking at various options that we can do to maybe power down some systems, which removes the heat that is generated by electronic systems. The radiators are used when the orbiter is in space to cool all those electronic systems. The flash evaporator system is used during ascent and deorbit and landing phases of the mission. So we will need the flash evaporator system for our landing phase. However, we don't need it while we're on orbit. So we're trying to give the flight controllers time to assess that situation and analyze all their data, check with other engineers, and look for the best solution to that problem. Mission elapsed time 7 hours and 16 minutes. This is Mission Control. This is Mission Control. The payload's officer has confirmed that the first solid rocket motor firing on the inertial upper stage was on time and a nominal length or normal duration burn. When we come back AOS with the crew at Guam in about 6 minutes, we'll be passing along that good news to them also. The second firing of the solid rocket motor on the inertial upper stage is set for just a few minutes after 11 p.m. this evening, about 11:02 Central Time. This is Mission Control.
Discovery, Houston. Half a day, Tau Tau, Guam, Discovery. We're talking to you through the Dan Dan tracking site. Greetings from the people of Guam, and congratulations from everybody at the Dan Dan station for a successful deploy.
Well, we sure appreciate it, but we know it's a big team effort, so thanks very much. Well, that's the second best thing we've heard today.
Okay, we'd like to talk to you a little bit about cabin temp and the high load problem. We'll give you a call in a few minutes about that.
Okay, good enough. And we'll be ready to downlink and deploy TV over Hawaii for you.
Okay, sounds good.
This is Mission Control. The tracking map on the large front screen at the front of the Mission Control room now shows the orbit track and the silhouette of the tracking data relay satellite following the first ignition of the solid rocket motor carrying that satellite on into geosynchronous orbit. As you can see, the orbit track is in a yellow color as opposed to the white of the orbit track of the shuttle. Right now, the tracking arc makes it look like the IUS is right in front of the shuttle. However, in space, it is actually at a much higher altitude than the orbiter Discovery.
Discovery Houston, we're 1 minute to Guam LOS, and we'll see you next at Hawaii at 7:41.
See you there.
This is Mission Control. We'll have contact with the crew again in about 6 minutes through the Hawaii tracking station. During that pass over Hawaii, we expect to get a playback of the videotape of the tracking data relay satellite deploy. That's scheduled for 6:18 p.m. Central Time. Once again, that'll be a playback videotape of the deploy of the TDRS satellite. This is Mission Control.
Aloha Discovery, we're talking to you through the Kokei tracking station for the next 8.5 minutes.
Oh, hello there. And loud and clear, but with an echo.
Discovery, everybody at the Kokei station sends you a very fond aloha and congratulations for a successful mission and best wishes for continued success.
Well, we appreciate that, and we appreciate all the work they put into helping us talk to you.
Roger that, and we're ready for the VTR playback now. Discovery Houston, go ahead and start the VTR dump. Discovery Houston, radio check.
Okay, Lacey, you should see, we got it queued up just about 15 seconds before the deployment.
Okay, go ahead and roll at any time, Mike.
Okay, you should be getting a picture now. This is really a pretty satellite, really some gorgeous views out the window through the deployment, and I hope we captured a lot of that on film. There you see it, very smooth separation. We heard nothing and felt nothing in the cabin when that separated.
It looks great, Mike.
Deployment from our point of view, and we understand it's well on its way to geosynchronous by now.
That's affirmative, and that's sure a beautiful shot there.
Yeah, back against the Earth really is spectacular. We let this camera run for quite a while, Lacey. You can take as much as you like. When you get tired of it, you can come inside and peek at Pinky on the mid-deck doing some protein crystal growth science.
Okay, we copy that. Sounds good. And while we're watching this, we've got a switch action over on L1 for you.
Go ahead.
Okay, we'd like you to check the H2O Loop 2 bypass mode to manual, and then take manual to decrease for 10 seconds.
Good work. That's complete, Lacey.
Okay, Dave, thank you. Discovery Houston, we'd like you to go ahead and drive that in manual a little bit further. We want you to go ahead and drive it, hold the switch until you see it interchanger at full decrease.
Okay, that's in work.
Discovery.
Go ahead.
Discovery Houston, we're ready to talk with you a little bit about the high load evap whenever you have a minute.
Stand by. with those words.
Okay, looks like to us that we probably had a buildup of ice in the high load during ascent, which has contributed to the problems there. And we're on mid-deck TV right now, by the way. Not sure how much of an ice buildup we have, but we are running, as you know, at the high set point on the Freon loops, and we also have the heaters on to help out with that problem. And we're going to stay in that configuration as overnight at least, and then look at it again in the morning. We've had you run the loop to full decrease, and we hope that that will bring down the cabin temp a little bit. And we'd like your feedback on the comfort level in the cabin right now. We've been looking at a couple of possibilities, SSR6 and also a part of the Group B priority power down as a way to reduce cabin heat loads if you think that's necessary. But we'd like some feedback from you on that.
I think we're pretty comfortable right now, Lacey. As a matter of fact, if we want to be a little warmer than normal, we come topside. If we want to be a little cooler, we go down to the mid-deck, and so far we're in good shape.
Okay, that sounds good. That pretty much syncs up with what we understand about 41G when we saw this same sort of thing before. Discovery, we've got about a minute to Hawaii LOS, and then we'll have a short dropout before we pick you up through TDRS. Discovery, I talked over you again.
Reports from downstairs, PCG activation complete.
Okay, we copy that. We'll talk to you through TDRS in about a minute.
Roger.
This is Mission Control. During that Hawaii pass, we saw some mid-deck and TV, and a really lovely video playback of the deploy of the tracking data relay satellite. We'll be picking back up with the crew in just a moment or two through the tracking data relay satellite east. Crew reported that the cabin temperature is comfortable, that they are not having any problems with the 88 degrees temperature inside Discovery's cabin, so the environmental systems flight controller will direct all his energies now to working on trying to bring the flash evaporator system back to full operation and continue using the radiators at a little higher temperature to try to help out the FIS to get back online. Pinky Nelson has reported that he has activated 2 of the mid-deck experiments, the PPE and PCG, and the PV toss, or physical vapor transport of solids, will be activated before the crew goes to sleep. We're about 2 hours away from crew sleep time. Mission controllers are tagging up for any pre-sleep activities or changes, things that need to be done before the crew goes to bed. At mission elapsed time, 7 hours and 52 minutes. This is Mission Control.
Roger.
Roger, Discovery. We're ready to do a pre-sleep tag-up with you whenever it's convenient for you. We've got all of our notes together, save 1 or 2 bits of information that are coming in. But we can start talking whenever you'd like to start listening to this.
Hawaii 1. Okay, Lacey, we're all ears. Pass.
Okay, Rick. First of all, from Inco, he wants you to know that your comm power amps and your ops recorders are running a little warm. So if you see some up arrows, you may have noticed that on the specs. However, he's watching that, and it poses no problem. He would like to know what the status of the teleprinter. We understand you were setting it up. Is it up and ready to go?
Lacey, the teleprinter is up and ready to go. The only thing we found on it was that it was powered on. It was launched with the power switch on, and so when we turned it on upstairs, the power went on, but I think it's fine.
Okay, we understand that. In that case, FIDO will be sending up a TRAJ message shortly, and there will also be a sleep vector coming on board in the near future. And Pinky, from you, payloads request that you pass down an ARC activation time.
Okay, I haven't done that yet, but I will when I do it.
Raj, understand that. We'll be listening up for that.
And I can do it right now if they'd like that. It comes later in the checklist, but I'll do it now if they want.
Okay, we'll check with them, and I'll give you a call back on that in a minute. I've got a note here on your pre-sleep cryo config if you're ready to copy that.
Go ahead.
Okay, on R1A2, cryo O2H2 tank 3 heaters A and B to auto. Cryo O2H2 tank 2 heaters A and B to off. And cryo O2H2 manifold valves, tank 1, that's 2 valves, to closed. And you can expect a cryo O2H2 spec 68 message when you close the manifold valves. And Discovery, if you've copied that, I've got a cabin pressure caution and warning limit that we'd like you to reset also.
Roger, go ahead.
Okay, on R13U, it's caution warning channel 4. We'd like the upper limit set to 3.8 volts, which is equivalent to 15.24 psi.
Okay, and we should tell you that we adjusted the backup CNW on the parameter. It was toggling around 15.24 earlier, so we bumped that upper limit up to 15.3 to get rid of those nuisance alarms.
Okay, we copy that. That sounds good to us. Okay, wake-up time in the morning will be 18 hours MET. Shortly, we're going to have a water dump message for you. And that's about all we've got for you right now. Is there anything you have for us?
We just want to tell you how pleased we are to be up here. Appreciate all the hard work that everybody's done down there, and we're real proud for NASA and the contractors in the country to be back into space.
Rick, thank you very much for those words. And for Pinky, your go to activate ARC and PV toss whenever you want to.
Okay, I'll get right on it. Thanks.
This is Mission Control. Pinky Nelson has already activated the phase partitioning experiment, mid-deck payload, and the protein crystal growth experiment in the mid-deck. He's working on activating the aggregation of red blood cells and also the physical vapor transport of organic solids experiment.
Houston Discovery?
Go ahead, Discovery.
Okay, ARC is activated. From the sounds of things, we've got happy blood, and the time was 8 hours and 4 minutes.
Okay, we copy that. Thank you much, Pinky.
This is Mission Control. At 7 p.m. Central Time, we will do a replay of all of the Flight Day 1 shuttle television. That'll start at 7 o'clock Central Time, and it'll be a replay of all of the television from Flight Day 1 activities. This is Mission Control.
Houston Discovery with an IMU line log.
Okay, go ahead, Discovery.
Okay, IMU line log. We had star 37 and a minus Y tracker, star 16 and a minus Z. Angle error was 0.02.
Angle errors, delta x minus 0.07 plus 0.07 minus 0.09, delta y's plus 0.12 plus 0.03 plus 0.11, delta z minus 0.17 minus 0.13 minus 0.16. Execution time was 8 hours, 14 minutes, and 10 seconds. Over.
We copied all, Dick. Thanks a lot.
This is Mission Control. That was pilot Dick Covey giving the inertial measurement unit alignment data to flight controllers. The crew will be going to sleep in about an hour and 42 minutes, and that's about 8:37 Central Time. We'll be coming up on playback of all of Flight Day 1 television at 7 o'clock Central Time. That playback will include all of the TV from launch, our payload bay, views of the payload in the bay, and the deploy downlink, the videotape we received from the crew earlier. At mission elapsed time 8 hours and 17 minutes, this is Mission Control.
Discovery Houston, would you check the KU band antenna heater circuit breaker on R15 and make sure that it's in?
Lacey, say again the circuit breaker you wanted us to check.
Raj, Dick, it's the KU band antenna heater circuit breaker on R15.
Okay, that circuit breaker is in.
Okay, thanks a lot.
Houston Discovery, the cabin fans offered a LiO cartridge changeout.
Thank you, Dick. We understand.
Dick Covey is describing a standard procedure that's done on the orbiter. A change out of a lithium hydroxide canister, which is a part of the air filtration system in the crew cabin, and that's part of the regular, normal, everyday housekeeping duties that are done on board the orbiter. While the change out of that canister is going on, the crew turns off the fan that circulates the cabin air. Once the new canister is in place, then they turn the fan back on. This is Mission Control.
Discovery Houston, I've got a water dump message for you.
Okay, go ahead.
Okay, Dick, use the Orbit Ops checklist, page 5-2, dump tank Bravo to 25%.
Okay, understand. Use the supply water dump procedure to dump tank Bravo to 25%.
That is correct.
Houston Discovery.
Discovery Houston.
Okay, Houston, we're going to send Earl Cook and all his good troops from St. Paul out to dinner. PV toss is activated. No anomalies at MET, 8 hours, 27 minutes, and 30 seconds.
Copy, 8:27:30. Thanks a lot, Pinky. They'll be real happy to hear that.
Okay.
This is Mission Control. Pinky Nelson gave us a time for activation of the physical vapor transport of organic solids mid-deck experiment sponsored by the 3M company. And that was activated at a mission elapsed time of 8 hours and 27 minutes. We have about 15 minutes remaining on this tedious pass, and the crew is in their pre-sleep activities, winding down their very long, arduous workday. They are scheduled to begin the actual sleep period at about 8:37 Central Time this evening. This is Mission Control.
Discovery, Houston.
Go ahead, Houston.
Roger, we're still working on a trajectory message, which we hope to send up on the teleprinter shortly. We're about 4 minutes from TDRS LOS, and we don't have anything else for you for tonight. So we're going to go ahead and say goodnight now and not plan on talking to you again. We certainly had a fun day working with you.
Well, Lacey, we've had a fun day too so far, and we appreciate y'all letting us settle down here. We look forward to working with y'all again tomorrow.
Roger that. Same here. Good night from all of us.
Well, good night from America's Spacecraft Discovery.
This is Mission Control. We're LOS from the TDRS, and we'll come back with the crew with AOS at Guam. However, at Mission Labs time, 8 hours and 42 minutes, Capcom Lacey Veach gave the final calls to the crew and wished them a good night sleep. Although the official go-to-sleep time is still about an hour and 15 minutes away, we'll try not to bother the crew again this evening so that they can have some time to relax and unwind after a long, arduous work day, very successful work day, with the successful deploy of the tracking data relay satellite on time. And the White Sands Ground Terminal reported a good first burn of the solid rocket motor, sending the payload on its way to geosynchronous orbit. Pinky Nelson has activated 4 of the mid-deck payloads: the protein crystal growth, the aggregation of red blood cells, the physical vapor transport of organic solids, and the phase partitioning experiment. All of those mid-deck payloads will continue to be in operation for most of the remainder of the mission. Crew wake-up time will be at a mission elapsed time of 18 hours even. And at mission elapsed time, 8 hours and 47 minutes, this is Mission Control. This is Mission Control. We're LOS Guam, and we'll have an AOS through Hawaii for data transmission after about 7 minutes. The members of the planning team have begun arriving in the Mission Control Center and are beginning their preliminary handover briefings from the Orbit 2 flight controllers. The official handover will take place in a short time between the flight controllers of the planning team and their flight director, who is Larry Bourgeois, lead flight director for STS-26. It's pretty quiet in the flight control room. ECOM officer is continuing to assess the situation with the flash evaporator system and to look at all the options for trying to bring that system back online and fully functional. It's operating partially right now, but we would like to have it back at full operation before landing. At mission elapsed time, 9 hours and 11 minutes, this is Mission Control. This is Mission Control at mission elapsed time 9 hours and 55 minutes. The crew will be going officially into its sleep period in about 4 minutes. The planning team is beginning its official handover now with its flight director, who is Larry Bourgeois, also lead flight director for STS-26 mission. Capcom Lacey Veach officially wished the crew good night at about 7:19 p.m. Central Time. And our final good night from the crew was from Dick Covey. Although that was a little over an hour before the official sleep time, we wanted to give the crew as much time to rest and relax as they could. They've had a very long work day. We expect that the planning team will be taking over the flight in about 45 minutes to an hour. This is Mission Control. This is Mission Control at mission elapsed time 10 hours and 22 minutes. Please note a change of time to 9:30 p.m. Central Time, which is 15 minutes earlier than previously scheduled in the TV schedule. This is the change of shift briefing with off-going Orbit 2 Flight Director Chuck Shaw. The briefing will begin at 9:30 p.m. Central Daylight Time, originating from the Teague Auditorium at the Johnson Space Center. The briefing will begin 15 minutes earlier than was originally scheduled. Please note the change in time. This is Mission Control. This is Mission Control. Please note a change of time in our change of shift briefing, which is coming up 30 minutes from now. That's set for 9:30 p.m. Central Daylight Time, which is 15 minutes earlier than originally scheduled. The change of shift briefing with off-going Orbit 2 Flight Director Chuck Shaw. The briefing will begin at 9:30 p.m. Central Time, originating from the Teague Auditorium at the Johnson Space Center. This is Mission Control.
This is Mission Control. The changeover is now complete. The planning shift is in place on console. Larry Bourgeois is the oncoming flight director. He's also lead flight director for STS-26. Capcoms are Catherine Sullivan and Pierre Thuet. During the handover briefing, the flight controller at the ECOM console said that they would be looking at some of the ways to get the ice out of the duct in the flash evaporator system. All systems appear to be working well at this time, and Capcom, when they took over, said that they were glad that they had a clean vehicle. We'll be looking at the change of shift briefing at 9:30 Central Daylight Time with off-going flight director Chuck Shaw. This is Mission Control at mission elapsed time 10 hours 41 minutes. This is Mission Control. The next TV event will be the change of shift briefing with off-going flight director Chuck Shaw. It will begin at approximately 9:30 p.m. Central Daylight Time in the Teague Auditorium. That's the change of shift briefing with off-going flight director Chuck Shaw. This is Mission Control. This is Mission Control. The STS-26 crew is now about an hour and a half into their sleep period. This is Mission Control, Houston. The IUS Tidris was deployed on time today and is now in its transfer orbit. Its second ohms burn is scheduled to occur at 11:02 Central Daylight Time this evening. That will take the Tidris to its geosynchronous orbit at approximately 22,000 miles above the Earth. It's rather quiet this evening in Mission Control because the orbiter systems are all working well. They have turned the heater up a little bit on the radiator and are trying to thaw the ice in the flash evaporator system ducts, and we'll know later whether that's successful or not. no changes to the crew activity plan are in work at this time. They plan to follow the timeline that was already scheduled. The crew will be waking up in the morning at mission elapsed time 18 hours, which is approximately 4:30 a.m. Central. Before going to bed, Pinky Nelson reported that the mid-deck payloads that had been planned to be turned on had been turned on and were working well. This is Mission Control at 11 hours 37 minutes. This is Mission Control. We are going to have television playback of the signing earlier this afternoon at the State Department of the International Space Platform Treaty. It will be shown at 10:30 p.m. Central Daylight Time. That's television of the signing of the treaty, the International Space Platform Treaty, at the State Department earlier this afternoon. This is Mission Control. This is Mission Control. We're now going to see video of the Space Station Agreement signing ceremony at the State Department this afternoon. This is Mission Control. We've just had confirmation that the second stage solid rocket motor had a nominal burn. It burned 108 seconds. It was planned for 109.3. It was almost perfect. It's very, very nominal, and payload's very happy. They're waiting confirmation from Sunnyvale that they're going to begin deploying the TDRS outboard solar panels soon, and we will be waiting to hear about that. This is Mission Control at 12 hours 41 minutes into the flight. This is Mission Control. Payload has just reported to flight that Sunnyvale has confirmed the IUS TDRS separation. It's now 13 hours 11 minutes into the flight. This is Mission Control. This is Mission Control, Houston. The TDRS deploy could not have been better today. It's on its way to geosynchronous orbit. The most recent events, I have a timeline for those. At 12 hours 48 minutes into the flight, the TDRS outboard solar panels were deployed. 1 minute later, at 12:49, the TDRS inner solar panels were deployed. At 12:49 and 47 seconds, the IUS RCS was enabled. That's the reaction control system on the IUS. At 12:56, 12 seconds, TDRS ground length antenna was deployed. The TDRS transfer to inertial TDRS transfer to inertial power was performed a little early, and it was planned that way. That occurred at 12:42. At 13:08:39, the TDRS IUS maneuvered to separation attitude. The separation occurred at 13:09:32. The IUS reaction control system performed to avoid there's a correction. That was TDRS transferred to internal power at 12 hours 42 minutes into the mission, which was a little earlier than it had been scheduled, but it was planned that way, and everything has worked just fine, and it could not have been better. This mission control at 13 hours 28 minutes into the flight. This is Mission Control Houston. Today on the Orbiter Discovery, 4 of the mid-deck experiments were also performed in addition to our successful deploy of the TDRS Tracking and Data Relay Satellite. They were the aggregation of red blood cells experiment, and it is going to be to study red blood cells and blood viscosity under low gravity levels. It includes intercellular forces, kinetics, and disease dependencies. This experiment will be conducted in conjunction with a ground-based version at KSC to allow for comparison of results. The ARC experiment consists of 2 sealed packages, the experiment apparatus container and the electronics equipment package. The 2 packages take up the space of 3 stowage lockers and are interconnected by an electrical power cable and a data cable. The ARC experiment has flown on 3 prior Space Shuttle flights. Another experiment was the phase partitioning experiment, also known as the handheld microgravity experiment, and it uses simple experiments to study low gravity effects on selected physical processes. This experiment will study the physics associated with the separation of 2-phase polymer solutions. In this case, dextran and polyethylene glycol. This could lead to a better understanding of a method used for separating biological cells. The third experiment was the protein crystal growth, which utilizes microgravity environment to grow protein crystals of a size and quality needed to determine the molecular structure of the proteins. Such information is essential for understanding protein functions and synthesis for drug design. The protein crystal growth experiment consists of a refrigerator incubator module which fits into the space of 1 mid-deck locker. The fourth experiment was the PVTOS, the Physical Vapor Transportation of Organic Solids, is a mid-deck experiment designed by the 3M Corporation. This organic materials processing experiment was designed to obtain thick, highly ordered crystalline films on selected substrates of subliminal organics. The PVTOS will use an experiment apparatus container configuration along with a data acquisition and control module. It has previously flown on STS-26. This is Mission Control Houston, 14 hours into the flight. This is Mission Control. We're now on orbit 11, and the orbiter is over South America. The TDRS was successfully deployed today, and it's on its way to geosynchronous orbit with its solar panels and antenna deployed. Everything went nominally on that. Mid-deck experiments that were activated today were the aggregation of red blood cells experiment, the phase partitioning experiment, the physical vapor transportation of organic solids experiment, and the protein crystal growth experiment. Those were in the mid-deck area. There are no changes to the crew activity plan. The crew will awake at 18 hours mission elapsed time, which is approximately 4:36 a.m. Central. and follow the mission plan to activate more mid-deck experiments during tomorrow's activities. This is Mission Control, 14 hours, 45 minutes into the flight. This is Mission Control Houston. You saw the screens go blank, and that's because they're resetting the channels and the charts, and everyone's going to reselect. It's just a normal procedure. Orbiter is now on orbit 12. Its mission elapsed time 15 hours, 14 minutes. This is Mission Control. The flight director is going to poll all the consoles to see if there are any messages for the crew to be radioed up in the morning. Guidance, Navigation, and Control has said that they would like to do an IMU align as soon as the crew wakes up. The IMUs are showing some drifting. This is Mission Control, 15 hours, 49 minutes into the flight. This is Mission Control. The crew cabin temperature was in the mid-80s when the crew went to sleep, and now it has gone down to 79 degrees, which should be fairly comfortable for them. The crew will be waking up in about an hour and 45 minutes to begin their day's activities. This is Mission Control, 16 hours, 16 minutes into the flight. This is Mission Control. The Orbit 1 team is beginning to arrive, and handover will begin shortly. It's been a rather quiet night. The Tracking and Data Relay satellite is on its way to geosynchronous orbit after near perfect burns of the two solid rocket motors. This is Mission Control, 17 hours, 2 minutes into the flight.
This is Mission Control at a mission elapsed time of 17 hours, 57 minutes into the flight of STS-26 Discovery, currently on orbit 13 over the central Atlantic Ocean. We've just completed the shift handover between the planning team and the Orbit 1 team. The Discovery is in a 178 by 162 nautical mile orbit. Most systems aboard the ship are clean. The comm system is in good shape. The inertial measurement units have been a bit erratic during the night. The gyros have been somewhat erratic, so they will be doing an IMU alignment 1 rev earlier on a night pass, and also coinciding with that a COAS calibration. COAS is the optical alignment site. Payloads officer during the handover reported that the burn for the inertial upper stage, tracking the data relay satellite to geosynchronous Earth orbit, was right on the money. The TDRS is at the proper location, all appendages deployed and in good shape. The team will be working and looking at the problems with the flash evaporator system. There's really no new news to report on that. It's stable, and they're continuing to look at just what that implies for getting the ice out of the system. They believe they'll probably stay in the current configuration with dual heaters on for most of today. And we're standing by shortly for the wake-up call from Mission Control to the crew. At a mission elapsed time of 17 hours, 59 minutes, this is Mission Control, Houston.
Good morning, Discovery! Good morning, Discovery! Good morning, Discovery. Rise and shine, boys. Time to start doing that shuttle shuffle. You know what I mean? Hey, here's a little song coming from the billions of us to the 5 of you. Rick, start 'em off, baby. The Hawkster to you. Are here.
And Discovery with that
Good
planning
morning,
shift will handle.
Houston. Good morning, Houston.
Good morning, Discovery. We have you loud and clear.
Hot and clear. Thanks for that nice wake-up music.
Well, we thought you'd appreciate that. And with that note, the planning shift will say a fond farewell to you for the day and hand it over to Orbit 1. We've got some ref mats and things on the way to you that Dave will discuss with you here in a minute.
Okay, thanks very much. You all sure did good work not waking us up in the evening.
This is Mission Control. We've just had the wake-up call go up to the crew here on Orbit 13. That was a tape supplied to NASA by a local radio station here in Houston, KKBQ FM 93Q. One of the disc jockeys there, Mike Cahill, put it together, and indeed that was the voice of Robin Williams. An arrangement worked out between Cahill and Mr. Williams. The wake-up call included Williams reenacting his Good Morning Vietnam trademark, although in this case it was Good Morning Discovery, and then also theme music from the television show Green Acres with somewhat modified lyrics. Capcom Kathy Sullivan is stepping off console now, and Capcom David Lowe will be taking over, and we'll be talking with the Discovery crew about the first items on this morning's schedule.
Discovery Houston, I've got one flight note for you, and then we'll let you have your post-sleep activities to yourself.
Okay, David, go with your flight note.
Okay, first of all, the morning mail we'll be sending up shortly. I also wanted to let you know that we've got a refs mat that we're about to uplink to you that is in preparation for your morning IMU align. And one note about that morning IMU align, because we had some overnight drifts on multiple IMUs, we are going to want you to do the IMU align one night pass early. So the maneuver will occur at 18:48. The align will occur at 19 plus 03. And then the COAS Cal at 19 plus 08. Over.
Okay, understand maneuver for the IMU line at 18:48, IMU line at 19:03, followed by COAS Cal 5 minutes later.
That's a good readback.
And we don't want to.
And Dick, just one more thing. In the Orbit Ops checklist, page 3-5, we do not want you to do step number 13. We have been seeing some higher temperatures, and we'd like you to leave that switch in the position that it's in currently.
Okay, we understand not to turn the mad strain gauge on.
That's affirmative.
Okay.
This is Mission Control at a mission elapsed time of 18 hours, 14 minutes. With an update on our briefing schedule for the next few hours, our next change of shift press conference with off-going planning team flight director Larry Bourgeois has been canceled. We polled the newsrooms around the network, and there doesn't seem to be a great clamor to hold that press conference, so we will cancel the change of shift briefing with Larry Bourgeois.
Discover Houston, we're about 2 minutes to LOS Tidris East. We'll pick you back up Yargady at 18 plus 41. Just a note for your information, we did not get the Earth observation information up in the mission summary. We won't be able to get that to you until the next Tidris pass.
Houston, we just got the last bit of that transmission. Understand the Earth obs data will come.
Discover Houston, that's affirmative. We're about 1 minute to Tidris East LOS. We'll pick you back up Yargady 18 plus 41. Earth obs information to come to you next Tidris pass.
This is Mission Control at 18 hours, 26 minutes. We've had a loss of signal through tracking and data relay satellite, Tidris East. Next acquisition through the Yargady station in about 15 minutes. Crew is currently in the post-sleep activity portion of today's crew activity plan, which consists of rubbing the sleep out of their eyes and getting breakfast ready and getting ready to go for the day. The one activity they have been or shortly will be doing is an IMU alignment. That'll be followed in a little more than an hour by the activation of the ADSF payload. Acquisition now 14 minutes away through Yargady, and this is Mission Control, Houston.
Discover Houston with you, Yargady UHF for 5 minutes. Discover Houston through Yargady UHF for 5 minutes.
I'm clear, Houston.
And you're loud and clear also. Discover Houston, 1 minute 30 seconds to LOS Yargady. We'll pick you up Canberra at 18 plus 49.
Okay, David, we'll see you there.
Discover Houston through Canberra for 4 minutes. And Discovery Houston, one note for you, we've got an orbiter state vector on its way. And also, with regard to your IMU line coming up, due to the poor performance of the IMUs, your Delta X, Delta Y, and Delta Z angle checks on Spec 21 may exceed decimal 80. No action required.
Okay, Dave, that's on its way, and we note your note about the Delta angle. Roger.
Discovery Houston, 50 seconds to LOS Canberra. We'll see you at Tidris East at 19 plus 09.
See you there.
It's Mission Control at a flight elapsed time of 19 hours 10 minutes. We've acquired signal through the tracking and data relay satellite, and we'll be in communications with the Discovery for the next 53 minutes.
And back with you through Tidris.
Loud and clear. We'll have the IMU line results for you shortly, and we're in the midst of doing the COASCAL.
Okay, Rick, copy that. And if you've got someone that can copy down a new attitude, I've got a new attitude that I would like you to go to post-COASCAL.
Go ahead, David.
Okay, it'll be target track 2, body vector 3, Omicron 270. That's the new part of it, the Omicron. That'll give you a nose-south attitude. The reason we'd like to do that is because we've been seeing some rather large gyro deltas on at least 2 IMUs. This is going to put us in an attitude for stars of opportunity, which will allow us to periodically assess the status of the IMUs throughout the day.
Okay, I copy our post-COASCAL. Maneuver will be to target 2, body vector 3, Omicron 270, be a nose south in order to catch some stars opportunity.
That's affirmative, Dick. And also, very shortly, we'll be uplinking page 2 of message 3 alpha.
Okay, we got stuff coming up right now.
It's Mission Control at an elapsed time of 19 hours 13 minutes. That last interchange between Capcom David Lowe and Commander Rick Houck aboard Discovery had to do with pointing for the Discovery, pointing and inertial reference. They've seen over the night some divergences that cropped up in the gyroscopes aboard the inertial measurement units. There are 3 aboard Discovery. As a comparison, the Apollo Command Service Module flew to the moon with 1 inertial measurement unit. The maneuvers that they do and have done and will be doing shortly have to do with lining Discovery up to be able to lock on to certain stars through the optical alignment site that the crewmen use. When they take those stars and their positions into the computer, that updates the orbiter's understanding of where it is in time and space. After they do a calibration of the optical alignment site, a procedure called a COASCAL, they'll low read up to the crew a new position, a new maneuver we'd like them to go to, that will put Discovery in a position to take additional stars of opportunity, just to add more fidelity to the inertial references aboard the spacecraft. So no problem there. The crew will be doing that shortly, and then they'll be moving into activation of some of the mid-deck payloads. Now mission elapsed time 19 hours 15 minutes. And this is Mission Control.
Houston, Discovery.
Discovery Houston, go ahead.
Okay, Dave, I've been on a secondary frenzy here for the last few minutes, and let me update you on where we are with all of these things.
Thank you, we're ready, go ahead.
Okay, I'm just going to page through the books, and I'll do it from front to back. IEF was activated at 19 hours and 10 minutes. The first two flashes went off right on time. It seems to be happy. ADSF sample 1 was started at 19 hours and 6 minutes, and it seems to be running well. Okay, ARC was deactivated at 19 hours and 1 minute. It seemed to run. We could hear it whirring and taking pictures all night long. Okay, and finally, TV toss successfully completed its first two cells. Cell 1 was completed at 13 hours, 4 minutes, 54 seconds. And cell 5 was completed at 17 hours, 56 minutes, 47 seconds. Over.
Okay, thank you. We copy all that. Thank you.
Okay, we're taking out the MLE.
Copy that.
Houston Discovery with the IMU line and COAS Cal data.
Rick, we're ready to copy.
Okay, IMU line, minus Y star 57, minus Z 16, angle error 0.02. Reading across the delta X is first, minus 0.12 plus 0.05, minus 0.07. Delta Y is plus 0.15, plus 0.11, plus 0.27. Delta Z is minus 0.15, correction, starting again, Delta Z is minus 0.58, minus 0.46, minus 0.51. Execute time, 19 hours, 4 minutes, and 30 seconds. How copy?
Rick, we got that all. Thank you.
Okay, the COAS Cal log, minus Z delta bias, 0.95, update time, 0 days, 19 hours, 17 minutes, and 45 seconds, over.
And we copy that too. Thank you. Discovery Houston, just for your information, we are about to uplink the orbit variable parameters.
Roger, Houston.
Discovery Houston, in order to get our stars of opportunity, we'd like you to take the trackers to track, please. And also at your convenience, we'd like an SM checkpoint.
Okay, we'll take care of both those. Thanks for the reminder.
This is Mission Control. Mission elapsed time 19 hours, 58 minutes. Discovery currently on orbit 14, passing over Eastern Africa. One of the sighting opportunities today is directly beneath Discovery about now. They're passing over a volcano in Ethiopia, which offers a chance to see some new lava flows. We regularly update the crew on interesting geological and...
Discovery Houston, we're about 1 minute to Tidris East LOS. We should have you through iOS UHF for about another 5 minutes, though.
To continue, we regularly update the crew on interesting phenomena around the globe that they might be able to photograph from the orbiter. One of those is underneath them right now, a volcano in Ethiopia. Another couple of opportunities that were mentioned in the morning mail to the crew on orbit 15. They'll be passing over the Yucatan Peninsula in Cozumel, and the desire is to see if there are any remnants of the damage of Hurricane Gilbert that may be visible from Discovery as they pass over. That pass will be at about a mission elapsed time of 21 hours, and then on the following rev at 22 hours 35 minutes mission elapsed time. Another opportunity to take a look at the eastern coast of Mexico, again to survey any damage due to Hurricane Gilbert, such as shoreline erosion and other features that may be visible from orbit. There are other opportunities today that Mission Control has outlined for the crew to take a look at some of the natural phenomena of planet Earth. For the mesoscale lightning experiment, the opportunities identified so far for today on orbit 18 at a mission elapsed time of 1 day, 1 hour, 22 minutes. Thunderstorms should be visible south-southeast of Hawaii or east-southeast of Guam when Discovery reaches the right position to take a look at those at 1 day, 1 hour, 22 minutes. Then on Rev 19 at 1 day, 2 hours, 52 minutes, they should be able to see a tropical storm east of the Philippines. On orbit 21, another tropical storm should be visible southeast of Cambodia. Mission elapsed time there 1 day, 5 hours, 54 minutes. Another item of interest from the morning teleprinter traffic to the crew, a piece of paper we refer to as the Flight Execute package, which is equivalent to the morning newspaper and contains updates to their crew activity plan for the day and other things such as Earth observations opportunities. A message was sent to the crew from the Air Force Satellite Control Facility at Sunnyvale, California, to let them know that the inertial upper stage solid rocket motor number 2 burn did take place on schedule at a mission elapsed time of 12 hours 29 minutes, which was just a little bit after 11 p.m. Central Daylight Time yesterday, the 29th of September. That burn resulted in placing the TDRS IUS stack in a 19,335 by 19,311 nautical mile orbit. Satellite Control Facility said to the crew in their message, quote, "The final velocity shortfall is an amazing 0.1 feet per second," unquote, which is a burn of some considerable precision. The Tracking and Data Relay Satellite, which will become TDRS West once on station and in operation, separated from the inertial upper stage at a mission elapsed time of 13 hours, 9 minutes, 32 seconds. We're now in contact with Discovery through the Indian Ocean Station. The crew is continuing in the crew activity plan in that part labeled post-sleep activity. They've already given Mission Control some data on start times and deactivation times for several of the mid-deck payloads. Pinky Nelson reported on this pass that the isoelectric focusing experiment was activated at a mission elapsed time of 19 hours 10 minutes. The automated directional solidification furnace, sample 1, start time was 19 hours 6 minutes. Aggregation of red blood cells experiment, ARC-2, the second one to fly on a shuttle mission, was deactivated as planned at 19 hours 01 minutes. Pinky reported that worked through the night. And then the PVTOS experiment, the physical vapor transport of organic solids, 3M experiment, successfully completed its first 2 cell runs, Pinky reported also. Crew also conducted maneuvers in association with inertial measurement unit alignments. But otherwise a relatively quiet pass here through Tracking and Data Relay Satellite and now the Indian Ocean Station. Loss of signal upcoming in about 3.5 minutes. Mission elapsed time now 20 hours, 4 minutes even, and this is Mission Control Houston.
Discovery Houston, we're about a minute and a half to LOS IOS. We'll see you at Yargady at 20 plus 16.
Hey there.
Discovery Houston through Yargady UHF for 8 minutes.
Hello, Houston. Houston, Discovery.
Discovery Houston, go ahead.
Raj, wonder if we could move up the KU band deploy about an hour or so. I don't
that doesn't interfere with my participation in the PPE.
Stand by 1, Dave. Discovery Houston for Dave.
Go ahead.
Yeah, Dave, you have a go to begin the KU band antenna deploy and activation. We'd like you to start it at Canberra so that we can take a look at it. We've got about 2.5 minutes to LOS Yargady. We'll see you at Canberra at 2:20 plus 24.
Okay, I'll get to work on that.
Discovery Houston through Canberra for 6 minutes.
All clear, and we're about to deploy the KU band.
Roger that.
Houston, we got a good deploy on the KU band. Looks like dual motor time.
We copy that, Dave. We've been watching.
It's Mission Control, the crew reporting. They've successfully deployed the KU band antenna for high data rate communications between the orbiter and the control center here. They're running ahead of the timeline and got it out at a mission elapsed time of 20 hours, 26 minutes, and some seconds over Canberra.
Discovery Houston, 1 minute to Canberra, LOS, Tidris East, next at 20 plus 46.
See you there, David.
Discovery Houston, back through Tidris East.
Loud clear, Houston. When we did the KU band activation on the self-test, we got all threes instead of the all eights that it called for.
Okay, Dave, copy all threes instead of all eights. We'll take a look.
Gotcha.
Discovery Houston for Dave.
Go ahead, Dave.
Yeah, with regard to your KU band activation, we have seen self-test fails in the past in flight vehicles. We think that you probably still do have a good KU band antenna. We're going to watch it in the comm mode down here on the ground. There is no further action required on your part.
Okay, thanks a lot.
This is Mission Control, mission elapsed time 20 hours, 51 minutes, mission elapsed time. Now in communication with Discovery here on the beginning of orbit 15 through Tidris East. First transmission from the spacecraft. Dave Hilmer's reporting that the self-test for the KU band antenna failed. That is a procedure that you do after you have deployed the antenna. Just checks out the electronics, make sure the system is up and running. The integrated communications officer here on the Orbit 1 shift, Harry Black, told Flight Director Milt Heflin that that's no cause for concern at this point. We've seen KU band antenna self-test failures in the past. That relates to a very tight set of timing sequences involved in that test, and it's easy to fail at points. The indication that the crew got was all threes on their readback instead of the expected all eights. The threes signify that self-test failed. So at this point, no further action required by the crew. The KU band antenna is deployed. INCO Harry Black will monitor, and we believe the antenna is in good shape and capable of sustaining high data rate transmissions. And we'll monitor. If any further action required, let the crew know.
Discovery Houston, I've got about 3 flight notes for you when you're ready to copy.
Stand by. Okay, Houston, go with your flight notes.
Okay, the first one has to do with panel A7 uniform. In order to enable us to better monitor the KU band performance, we'd like you to take the video output downlink, that's a push button downlink, and then under video input, push the test push button. And that again will give us, enable us to monitor the KU band performance a little bit better. Also, we've noticed the cabin pressure is down to about 14.6 psi. We would expect to see some flow into the cabin. To check that, we'd like you on panel MO10W to check that the 14.7 cabin reg inlet system 1 valve is open and that the system 2 valve is closed. And you can report back to us when you get that done. And the final flight note, we have been watching in temperature on SM spec 89. It's your ohms crossfeed center, the center crossfeed aux, has been pretty stable at about 68 degrees. We would expect that to fluctuate a little bit more. In order to check that out, on panel A14, we'd like you to take the ohms crossfeed lines A to off and B to auto. Over.
Okay, David, we got the starting backwards there. A14 ohms crossfeed A is to off, to B is to auto. We've got the 14.7 cabin reg system 1 open, 2 closed. And Houston, on the A7U, we've got the video output to downlink. And say again what you wanted for the video input.
Video input to test, please.
Okay, there we got that selected now.
Okay, Dick, thank you. And Discovery, we've got a trajectory message on its way at this time.
Roger.
It's Mission Control at 21 hours 31 minutes. Mission elapsed time. Discovery now on orbit 15, passing over Central Africa. Another 9.5 minutes or so left in this tracking and data relay satellite pass. Crew has just recently completed a supply water dump, and the electrical environmental systems officer here on the ground says all the signatures looked good. So that was a successful procedure.
Discovery Houston, we're 1 minute to Tidris East LOS. We'll still have you UHF through IOS for about another 4 minutes. Then we should see you through Yargady for about 9 minutes at 21 plus 51.
Roger.
And also, Dick, just for your information, switching to the B heaters on the ohms crossfeed line seems to have done the trick.
Okay, that's good news.
It's Mission Control Houston at a mission elapsed time of 21 hours 45 minutes. Discovery on orbit 15 over the Indian Ocean. Just concluded a pass through the tracking and data relay satellite. Various things happening as we progress into flight day 2. Just as they were going over the hill, Capcom David Lowe reported indications here on the ground show the actions taken with regard to temperature sensor on one of the orbital maneuvering system crossfeed lines appears to have been successful. The problem that we noted was in the orbital maneuvering system crossfeed line C temperature, which is nominally supposed to cycle between several different readings, and it did that correctly until approximately 6 hours into the flight. Since then, the measurement has been nearly constant, which indicates either an instrumentation problem or a thermostat problem. So the procedure to check it out was to switch the B line crossfeed heaters on as soon as was able to do so, and the crew did that this morning. The propulsion systems officer reporting that looks like it worked. They're seeing cycling and all the right numbers coming down from Discovery. On this last pass, they crossed over the Yucatan Peninsula, the Mexican coastline, and at a mission elapsed time of 21 hours or thereabouts, they had an Earth observation opportunity to take a look at the Yucatan Peninsula and Cozumel from orbit to see what damage may be visible wrought by Hurricane Gilbert. They have a series of Earth observation targets that we feed up to them daily for interesting geological or other phenomena around the planet. On the next rev, they've got another Earth observations opportunity coming up. They'll be looking at the eastern coast of Mexico, also to see what sort of damage they may be able to view from orbit due to Hurricane Gilbert. Specifically, they'll be looking for any evidence of shoreline erosion. The mesoscale lightning experiment is also going to be up and running today. There are three good opportunities that have been delivered to the crew so far via this morning's teleprinter uplink. The first comes on orbit 18, mission elapsed time 1 day, 1 hour, 22 minutes. They'll be looking for thunderstorms south-southeast of Hawaii and east-southeast of Guam on Rev 19, mission elapsed time 1 day, 2 hours, 52 minutes. They'll be looking for a tropical storm east of the Philippines. And on orbit 21, mission elapsed time 1 day, 5 hours, 54 minutes, they'll be in a position where they may be able to see a tropical storm southeast of Cambodia. Those viewing opportunities for the mesoscale lightning experiment are part of an effort to understand how lightning works and how large storm systems can interact over vast expanses of the globe. We've flown lightning experiments before on STS-2, on STS-4, STS-6, and we may indeed fly several more here on the next few upcoming flights. Meanwhile, our TV plans for the morning continue to be put into final form. We're expecting television to come down from the Discovery upcoming on orbit 17. We hope to see some views from the middeck, see what the crew's doing up there as they work with some of the middeck payloads. That downlink should take place at a mission elapsed time of 1 day, 0 hours, 2 minutes through Hawaii, or at about 10:39 Central Daylight Time this morning. Also on this last pass, just prior to acquiring through the tracking and data relay satellite, when the Discovery was passing through the Canberra station, we were receiving data and talking to the crew, and they were ahead of the timeline. They deployed the KU band antenna. Part of that procedure calls for doing a self-test of the antenna. The antenna failed it, but that is not unusual. We've seen that before. It has to do with some very tight parameters that the computer has to sync up to. Over the last pass, the Integrated Communications Officer, Harry Black, reported the KU band antenna performed well, and we see no signatures that would indicate a problem. We're standing by now for acquisition through the Argody station, and this is Mission Control.
Discovery Houston through Argody, UHF for 9 minutes.
That's clear. That's clear, Houston, LS.
And you're loud and clear also. Discovery Houston, we're about 1 minute to LOS Argody. We should have about a 20-second dropout and then pick you back up Canberra.
Okay.
Discovery Houston through Canberra for 5 minutes.
Okay.
Discovery Houston, we're about 2 minutes to LOS Canberra. We'll see you Tidris East at 22 plus 25.
Roger.
And Discovery also, with your concurrence over Tidris East, we would like to take control of the cameras for some video of the payload bay. So, again, with your concurrence, we'd like you to take the TV control switch to command once we get over Tidris East.
Okay, that won't be a problem. We'll let you do that. And we might even have some cabin TV.
Okay, sounds great.
It's Mission Control. Discovery out over the southern Pacific Ocean, just passed out of range of the Canberra tracking station, and we'll be coming up for teeter's acquisition shortly in about 13 minutes. When we do, shortly after we pass into the range of teeter's east, we expect to be taking some television from Discovery, some unscheduled payload bay views that the crew is going to be kind enough to send down to us. That should take place around mission elapsed time 22 hours 25 minutes, or approximately 9:02 a.m. Central Daylight Time. Again, unscheduled shuttle television expected on orbit 16 at about 9:02 a.m. Central. This is Mission Control. It's Mission Control, Houston. About 2 minutes remaining before we acquire signal again through teeter's east. Discovery will be sending us some unscheduled shuttle television here on orbit 16 through the tracking and data relay satellite. We expect the downlink to take place at a mission elapsed time of 22 hours 25 minutes, or about 9:02 a.m. Central Daylight Time. Now a minute and a half remaining until acquisition. This is Mission Control.
Discovery Houston, back with you through TDRS.
Roger, and we'll put the TVs in the command for you.
Okay, thank you. And one other thing, we've got a gyro compensation for all 3 IMUs on its way. A good note is that the gyro drift that we've been seeing is not as bad as we thought it was. This compensation should take care of it.
Okay, that sounds good, and you can take either mid-deck or flight deck TV if you want it.
Okay, Dick, thank you. And Discovery Houston, we're going to move to the inside cameras at this time.
All right.
And we've got some real good mid-deck video. It looks like fun.
We talked to you, but we couldn't find the microphone.
Pinky and I have been spending the morning working on PPE, the phase partition experiment. And it's a little experiment that tries to look at the fluid dynamics of separating 2 different phases of materials, and it can be used in a lot of ways. One of the ways might be in medical experiments where you have malignant and non-malignant cells, and you can put them together in this mixture, and as the phases shift or go into their own particular solution, they end up separating out the cells. Pinky and I have been shaking up the phase partition experiment. It's a lot like shaking up vinegar and oil. In 0G, it has a somewhat different mixing. It's more like an egg white and an egg yolk. I guess one of the things that this can show is the use of people in space. We can look at the experiment, see if there are any unique changes and observe them. We can take pictures as we see unique changes and possibly modify the experiment with the concurrence of the PI, of course.
Discovery Houston, Dave, thanks a lot for those words. I just want to let you know also that we have lost TV downlink because of blockage on the antenna. We should be getting that back shortly.
Okay.
And Discovery Houston, we got some video of the mid-deck back again.
Roger. Houston, Discovery.
Discovery Houston, Pinky, go ahead.
Okay, just a little thing for the PI on the PPE. You can see this Rube Goldberg contraption we've got this thing set up with all the arms and that, and it's kind of flimsy. We were thinking about next time that we run this later on today, mounting the light, putting some Velcro on it and mounting the light on the surface of a locker so that it's held down a little more securely and we won't be shaking it, you know, even as slightly as we are by turning the light on and off. You might ask them if that configuration's okay with them.
Okay, Pinky, we certainly will. Thank you.
Okay.
we've also noted on that one that the light doesn't seem to affect the temperature at all, and if we could leave the light on, that would reduce the impact we have on the experiment by putting small motions in it when we turn the light on and off.
I think you will ask about that also.
And Dave, you can tell the experimenters, all of us are in the process of doing our medical DSOs, and Pinky and I, in between PPE pictures, are going to be doing the otter goggles.
Okay, that message is going. Discovery Houston, for Pinky, we've already got word back from, with regard to PPE. It is not okay to leave the light on, but it is okay to mount it where you would like to mount it.
Okay, that's what we'll do.
And Discovery, we're up on the flight deck now, too.
Houston, we're coming over the eastern coast of Mexico right now and trying to get some pictures to see if we can see any damage that was done by that hurricane that missed us.
Copy that. And Discovery Houston, we've got payload bay views at this time.
Looks pretty cloudy in Houston today.
That's affirmative.
New Orleans is nice and clear, though.
From what we can see, you guys have a fantastic view. And Discovery Houston, we're back in the middeck.
Okay.
And in fact, we're on the flight deck now.
All right, and we're out here taking pictures of some great-looking spiral eddies for Dr. Stevenson.
He'll be happy about that.
And I'm sucking out a piece of cotton for the medical folks.
And they'll be happy about that. And Discovery, we're back out in the payload bay again.
Houston, Discovery.
Discovery Houston, go ahead.
Roger, for information, we're recording some TV down in the middeck of Dave Hilmer's doing the otter goggles.
Okay, thank you. Appreciate that.
And slightly out of view is Pinky Nelson helping Dave record the data.
And we're looking at it now. And Discovery Houston, we just lost the picture because of antenna blockage. Looks like we won't get any more this pass. We appreciate it, guys. We enjoyed it.
You're welcome.
Houston, mission elapsed time 22 hours, 58 minutes. Concludes for now our television from Discovery, geometry being such that the KU band antenna is in blockage, so we won't be getting any more TV on this Orbit 16 pass. Rather lengthy television downlink showing us the activities underway this morning on Discovery. Included views of mission specialists downstairs working on some of the middeck experiments. Upstairs on the flight deck, pilot Dick Covey and Commander Rick Houck looking out the overhead windows on the aft flight deck at some of the spots along the Gulf Coast as they passed over on this rev. One of the things they were attempting to do was get some photography looking down on the east coast of Mexico, see if there's any evidence from orbit of shoreline erosion due to the passage of Hurricane Gilbert some days ago. About another 19 minutes remaining in this pass through Tidris East on Orbit 16, and this is Mission Control, Houston. A satellite playback beginning at a mission elapsed time of 23 hours and 3 minutes, or at about 9:40 this morning.
Discovery Houston, we're about 2 minutes to Tidris East LOS. We'll see you at Yargady at 23 plus 28. And Discovery, just one more thing I meant to get to you. We earlier did receive a very good TV test pattern, and we got a good ops recorder dump last pass. So we on the ground are considering your KU band antenna to be a good antenna.
Okay, we understand KU band is good.
Mission Control at mission elapsed time 23 hours, 19 minutes even. Just had loss of signal through the tracking and data relay satellite as Discovery heads out over the Indian Ocean. Next acquisition will come through the Yargadee station in a little more than 8 minutes. Meanwhile, our playback of the Orbit 16 TDRS views that we got from Discovery on the Orbit 16 TDRS pass, that playback continues and will be in progress for another several minutes. This is Mission Control.
Discovery Houston, Yargadee UHF for 9 minutes. Loud and clear. Discovery Houston, we're about 1 minute to LOS Yargadee. We are supposed to pick up Canberra in about another minute. However, we've got a real low elevation on that. If we don't see you at Canberra, we'll see you at TDRS at 1 day, 0 hours, 2 minutes.
Okay, we'll see you there.
It's Mission Control at 23 hours, 37 minutes mission elapsed time. Currently Discovery over the Australian continent. We are expecting upcoming on Orbit 17 through tracking and data relay satellite some more television from Discovery. That downlink should take place at a mission elapsed time of 1 day, 0 hours, 2 minutes, or a central daylight time of 10:39 a.m. this morning.
Discovery Houston through Canberra for 2.5 minutes.
Okay, loud and clear.
And we got you loud and clear also. Discovery 1 minute to Canberra LOS. See you TDRS East, 1 day, 2 minutes.
Okay.
Mission Control Houston, mission elapsed time now 23 hours, 51 minutes. Discovery is approaching acquisition through the Hawaiian station, and after passing through that station, we anticipate taking some television here on Orbit 17 through the tracking and data relay satellite. Downlink would be at 1 day, 0 hours, 2 minutes, Central Daylight Time of 10:39 a.m. And in answer to numerous queries that were prompted by the last downlink that we got on the last orbit about the Earth, towards the tail end of the TV pass that we took previously, viewers could see Pinky Nelson with a what looked to be a white wrap of some sort around his head. That's part of the medical detailed supplementary objectives for this flight. We'd have a series of DSOs and DTOs, detailed test objectives, on any given mission. That particular one was the otolith tilt translation reinterpretation, DSO 459, the objective of which is to collect data which will allow development of a trainer to pre-adapt astronauts to the sensory changes produced by microgravity. 2 crew members will be working together on this flight to obtain data regarding their perceived positions each flight day. 1 crew member will wear the OTTR goggles for data collection of the otolith response. So that's what that was. Standing by now for acquisition through Hawaii and television following that. This is Mission Control Houston.
Discovery Houston, it looks like I lied a little bit earlier. We got you through Hawaii now for about 5 minutes.
Okay, won't hurt your credibility any, dear.
Discovery Houston, 1 minute to Hawaii, LOS. We'll see you, TDRS, in about another minute.
Roger, Houston.
Discovery Houston, back with you through TDRS.
Roger, Houston, line clear.
And you're loud and clear also.
Houston, Discovery.
Discovery Houston, go ahead.
Roger, we're prepared to give you some downlink TV from the mid-deck, talk a little bit about some of the secondaries, and then come up to the flight deck, talk a little bit about taking pictures, and then back down to the mid-deck and let Mike Lowndes tell you a little bit about how we stow the pole and so forth. So whenever you'd like to do that, let us know.
Discovery Houston, Rick, we are not quite ready yet, but we'll let you know.
We're standing by.
Mission Control Houston at 1 day, 0 hours, 14 minutes. We've been configured to take some television.
Discovery Houston for Rick.
Go ahead.
Yeah, Rick, we're going to have to delay taking some TV for a little while. We're working from the ground of what appears to be some kind of a problem with the K-band antenna. Turns out the commanded and actual pointing positions do not agree. From the ground, we've taken it to standby and back to on, and that has not seemed to help. There's no action required on your part at this time. We're going to troubleshoot a little bit more from the ground and then get back to you.
Okay.
This is Mission Control. We had anticipated taking television now as David Lowe, the Capcom, just relayed to the crew indications coming down to us that the actual position of the KU band antenna and that position to which it should be commanded are different. Why is not certain at this point. It's a stable situation, no problem, nothing the crew needs to go off and work at the moment. What it does do, however, is delay our television for a time unknown at this point.
Family down in Fort Walton Beach, Florida right now. They're real clear down there today. It's a pretty view.
I'm sure they're following it very closely, Dick.
This is Mission Control again. So as pilot Dick Covey says hello to his family in Fort Walton Beach, Florida, Integrated Communications Officer Harry Black continues to work a problem with the KU band antenna, trying to understand what is causing the divergence between where they think the antenna ought to be and where it actually is. When they first discovered the problem, they commanded the KU band antenna system to standby and cycled it back on. No joy fixing it. So they're still looking. No action required of the crew at this point for any troubleshooting. But what it does do is delay the television that we had anticipated here. Some views from the cabin, both the middeck and flight deck, to get a look at activities there. And we'll pass on word when we might expect it as that becomes available. 1 day, 0 hours, 17 minutes. This is Mission Control Houston.
Discovery Houston for Rick.
Roger.
Yeah, Rick, we are not having very much luck troubleshooting the K-band antenna problem, so it looks like we will not get any TV downlink this pass. What we would like you to do at this time is to go ahead and maneuver back to your nose south attitude, if you could, please.
Okay, the 270 Omicron, we'll do that.
That's affirmative, thank you. Discovery Houston, we're about 2 minutes to TDRS East LOS. We'll see you at Yargady at 1 hour, 4 minutes.
Okie dokie. We're enjoying lunch.
I bet you are, and Rick, we're working on some troubleshooting procedures down here for the K-band antenna.
All right. Well, we'll enjoy using our mechanical talents.
You might have to.
It's Mission Control Houston. We've had loss of signal through the tracking and data relay satellite. Expecting acquisition over the Yargady station in about 7 minutes. On this last pass, we encountered problems with the KU band antenna that flows both high data rate communications and in many cases television to the ground. We had hoped to take television scenes from Discovery on this last pass. However, that wasn't possible due to the difficulties in pointing and commanding the KU band antenna. A little bit about that device. It is stowed inboard on the sill of the payload bay just aft of the crew cabin until such time on orbit as it is ready to be used, and then it swings out and is deployed in that manner. When we have a satellite such as the TDRS in the bay, as we did yesterday, there are oftentimes with various payloads, especially and specifically a TDRS, requirements that keep you from flowing those high data rate KU signals out of the payload bay. So it wasn't until this morning that we deployed the KU band antenna following the departure of TDRS yesterday. When it was deployed over Canberra a couple of orbits ago, Dave Hilmers then executed the next step in that sequence, which is to conduct a self-test of the unit. It failed the self-test, but that in itself at the time did not seem suspicious to the INCO officer here, the Instrumentation and Communications Officer, simply because we've seen that signature before with this particular piece of equipment. The KU band antenna has some very tight time sequences within its test of itself, and it's not uncommon to fail, but also to be in, for the test to fail, but for the satellite dish itself to be in good shape and good working order. And indeed, on the following TDRS pass, it was so. At any rate, it showed up with problems on this most recent pass through the TDRS East signal coverage area. The problem appeared to be in pointing and commanding, and it boils down to the fact that the dish was facing in one direction but should have been commanded to be facing in a different geometry. So they're still working it, and we will let you know again on that one as more information develops. Right now, Discovery out over the Indian Ocean. We're at 1 day, 0 hours, 59 minutes, and this is Mission Control Houston.
Discovery Houston through Yargady for 8 minutes, UHF.
Last clear, David.
And you're loud and clear also. Discovery Houston.
Go ahead.
Yeah, Rick, just a heads up for this upcoming Hawaii pass. Prior to Hawaii, we would like you to set up your payload bay cameras. I guess that would most likely be cameras B and C, so that over Hawaii, we down here on the ground can get a good view of the K-band antenna. We want to see if the positions that we're reading here on the ground coincide with what it looks like the antenna is pointed at. Another thing, if you can verify at this time that the KU power switch is in the on position, we'd appreciate it.
Okay, wait one. Okay, the KU band power switch is on. We're in command right now, of course.
Okay, we copy that. We're going to lose you here in about a minute and a half. We'll pick you back up at Hawaii at 1+29. And another heads up for you, it looks like we're probably going to ask you to do some manually slewing of the antenna, but hold off for our call on that.
Okay, thank you for that planning factor.
Discovery Houston, thanks for the wake-up music.
There's lunch music.
This is Mission Control at 1 day, 1 hour, 13 minutes. Loss of signal through the Yargadee station. And as we were passing over the hill, we got some unexpected music from the crew. They're in the midst of lunch right now. And most of us here think that was Marvin Gaye. At any rate, the flight director, Milt Heflin, unaccustomed to music on his air-to-ground loops other than during crew wake-up, asked the ground controller, Chuck Capps, which way that music was going, up or down, and the GC officer responded, "I sure hope it's coming down, flight." During that pass, Capcom David Lowe passed on to the crew some plans we've got for looking at the KU band antenna and seeing what troubleshooting procedures might be useful in dealing with those difficulties. And that will be the subject of the television we expect to see through Hawaii, possibly also through the Vandenberg and Mila stations here on Orbit 18. The first downlink should come to us at a mission elapsed time of 1 day, 1 hour, 30 minutes, or around 12:07 p.m. Central Daylight Time. The instrumentation and communications officer, Harry Black, as part of the troubleshooting procedure, reports that the experts in his discipline are not completely confident that the telemetry they are seeing that indicates the geometric configuration of the dish, which way it's pointed. Not sure that telemetry is absolutely accurate. And if not, that would account for some of the problems they're having in the difference between which way the antenna is pointing and which way it's been commanded to point. So, empirical evidence being the best in many cases, they will fire up a couple of the payload bay television cameras and ask the crew to train those on the dish and take a look at it, compare its position with the position that it is indicated to be in by the telemetry. The next phase of that troubleshooting procedure, if it were to be necessary, would be to ask the crew to do some manual movement of that dish through switch throws on board. And the conservative approach that they would take in those movements would be any movement that the antenna takes should be toward the stowed position, just in case there is a problem that we can't fix while we're up in orbit. We'd be that much closer to having the antenna in its best configuration for entry. So taking no chances, that's which way they'll move it if that becomes necessary. As we approach acquisition through Hawaii, the Orbit 1 team is talking with counterparts and colleagues on the Orbit 2 team as the shift handover here in the Mission Control Center has begun. It'll go on for another hour or so. So for the crew, it's lunchtime. For the Orbit 1 flight controllers, it's the end of a long day. And we'll be looking forward to some television through Hawaii upcoming shortly. This is Mission Control, Houston.
Discovery Houston, back with you through Hawaii, and we're picking up some good TV.
Okay, unfortunately, the front angle is not very good for the black and white camera. Charlie, I've panned it away from the KU band because it was ATC was cycling on it.
Okay, we copy that.
Camera D is pointed directly at the electronics package, the pedestal rather. But I'm not sure what you can get out of that.
Okay, Pinky, we're taking a look at it. As you said, the lighting's not too great, but we're looking at it.
And Houston, I've given you command to move the antenna, or the TV says EC set.
Okay, Rick, thank you.
Houston, I can tell you where it looks like the dish is pointing just looking out the PLT's window.
That's affirmative, Rick. It is following the commands at this time. And we're still talking about it down here.
Okay.
And Discovery Houston, at this time we would like you to manually slew the antenna to the stow position. That stow position is elevation minus 27 degrees, azimuth minus 123 degrees. Again, that's manually slew it at slow rate, please.
Okay, Henry.
This is Mission Control. We're taking a variety of views from the payload bay cameras of Discovery. Effort to take a look at the KU band antenna. Inco Harry Black reports that when they did come up over Hawaii and got a look at which way the antenna was pointing, it was obvious that it was following the commands that had been sent. It was tracking its command path. However, they're still not sure what the failure mode was when they try to bring it up and use it on the last TDRS pass. So not being sure of that, what they've asked the crew to do also as part of the checkout here is just to manually slew the antenna, but to be conservative, to slew it toward the stow position.
Discovery Houston, just for your information, we are controlling the payload bay cameras at this time.
Okay.
Discovery Houston, 1 minute to Hawaii LOS. We'll pick you up TDRS East in about 2 minutes.
Okay.
It's Mission Control. We're losing our video signal through the Hawaii station. We will come out of the Hawaii footprint and enter coverage of TDRS, then drop down to the Vandenberg station for some more television. As we left and lost the television from the orbiter over Hawaii, Commander Houck had gotten the right elevation on the antenna and was working on its azimuth. A note for those not familiar with the KU band antenna and its operations: it is again a dish that's used to send and receive high data rate transmissions.
Discovery Houston, back with you through TDRS.
Okay, and Dave is sweetening up the angles right now.
Okay.
That motion that you see right now is self-induced.
Okay, Rick, thank you.
You want us to move it out of that area?
Stand by 1, please.
Houston, Discovery.
Discovery Houston, go ahead, Rick.
We're hesitant to leave this in that limit cycle area.
Rick, we understand that, so are we. We were discussing possibly completely stowing it at this time, but we need another minute or so.
Special Control, this video coming to us through the Vandenberg station. As Discovery nears the west coast of the United States, we're seeing the KU band antenna looking from a camera in the aft part of the payload bay forward. For reference, the crew cabin would be to the left of the picture. Commander Houck reported a moment ago that Mission Specialist Dave Helmers was executing the procedures for manually slewing the position of the dish. The oscillation that we're viewing now is something that should not be happening, although it is not well understood. They believe they've got good possibility to get the manual procedures to stow the dish.
Discovery Houston, at this time, we would like you to take the power switch to standby, please.
Hotel. Stop.
Okay, it looks like it stopped the motion from here.
All right.
Mission Control, we're passing out of the coverage range of the Vandenberg station, passing through a keyhole. Next possible television here would be through the Mila station shortly. They believe here in Mission Control that the antenna dish itself is stable and it's stopped oscillating when they took it to the standby mode. Would probably be instructive to note that this represents an inconvenience, does not represent any kind of major systems failure or emergency of any sort. The KU band antenna is one of many ways we have to get data back and forth from the orbiter, and also one of several ways we've got to flow television. And voice comes down through other routes also. It's important for clearances and proper configurations to have the KU band antenna stowed for entry, and that really is the bottom line issue being worked here. They would like to make sure they understand what's going on with the dish so that they don't stow it and not be able to use it for the rest of the flight, when in fact they might be able to use a troubleshooting procedure and bring it back up to its full capacity. So they would prefer at the moment to think about it, let the satellite stay in its present configuration. There's no time threshold that they're working against. It's stable, and they can take their time and think about it.
Go ahead.
Yeah, with regard to your K-band antenna, it looks as though you're in a stable configuration right now. We'd like you to just leave it in the current configuration. We're doing a whole bunch of talking down here right now, and we'll get back to you when we can on it.
Okay, we'll be here.
It's Mission Control, Houston. We're now at 1 day, 1 hour, 53 minutes. Still taking some video from Discovery, looking at the KU band antenna. Viewers will note that it's not moving, which is exactly what we'd like it to be doing right now. Is remaining motionless. Taking this transmission through the Mila station, and we're looking at the KU band antenna from camera C on the aft bulkhead of the payload bay of Discovery. Camera C is a monochrome black and white camera. One of the considerations flight controllers are discussing now is that if you stow the KU band antenna, there are some pins that fall into place to keep it in that stowed position. And if it were to have certain problems within its systems, some of which would seem possible given the situation they find themselves studying now, they might not be able to get it unstowed if they're able to fix it. So the discussion is just to make sure they don't go too far too fast. If there is a way to analyze the problem prior to stowing the antenna, that's what they'd like to do. The reason stowage is considered to be a good, safe, conservative approach is simply to preserve a piece of government-furnished equipment. There's no issue relating to safety or impact to timeline or the crew or the vehicle. Were the antenna to be stuck in its extended position, and were it not able to be stowed, there are devices built into that appendage which would sever it and jettison the antenna to allow closure of the payload bay doors. So in point of fact, since the majority of systems aboard Discovery are sparkling clean, and there's not a lot of work going on following a great many systems problems, this has got a lot of people's attention. Discovery now passing out over the Caribbean Ocean on orbit 18, still sending us video via S-band through the Mila station. Discovery's apogee is 177.3 nautical miles, her perigee 162.8. About another 2.5 minutes left in this Mila pass, and another 34 minutes left over the tracking range of the TDRS satellite. This is Mission Control.
Discovery Houston for Pinky.
Okay, go ahead.
Yeah, Pinky, I've got a note with regard to the questions that you asked earlier on PPE photography. After payloads officer talked with the PI, we've got two better answers for you. First of all, the PI concurs with mounting the light box to the locker. However, he requests that the orientation of the light box with respect to the orbiter axes be noted on the voice recorder. Secondly...
Okay, that's part of the procedures anyway.
Okay. Secondly, he agrees to leave the light on between the photos. However, if you should see that the temperature increases by 1 degree centigrade, turn the light off between photos. Over.
Okay, sounds like a good idea. And you might tell the PI we've had his PPE up now for the since the first time we had it out, and we're trying not to disturb it much until we start again, so we'll get some pictures of after it's been sitting there for, I don't know, 4 or 5 hours at least.
Okay, we'll pass that along. Discovery Houston, one last note. We would like you to cycle through all the payload bay cameras and turn them off at this time to keep them from overheating, please.
Okay, we'll do that.
Okay, and with that, we're going to turn this over to the Orbit 2 team. See you tomorrow.
Nice working with you, Dave.
This is Mission Control. We have about 21 minutes remaining in this TDRS pass. Here in Mission Control, the Orbit 2 flight control team, led by Flight Director Chuck Shaw, has assumed control of the flight. Flight controllers are still looking at the problem with the tracking data relay satellite antenna, the KU band antenna that we use to transmit through the TDRS East. That antenna would not go into its fully stowed position earlier when the crew tried it, and we're still looking at that on TV when we have an opportunity to check it out. The communications officer cannot yet determine what kind of failure has caused the problem. It is very similar to a problem that was experienced on Mission 41G. They are continuing to look at that and decide what options to take. If we can get the antenna close enough into the stow position that the pins can go in and lock it down, it will be stowed for the remainder of the mission. At mission elapsed time 1 day, 2 hours, and 21 minutes, this is Mission Control.
Discovery Houston, we are 2 minutes till TDRS East LOS. Yargity next at 2 hours, 41 minutes. Orbit 2 team is on console, looking forward to working with you today.
Okay, we'll talk with you, Yargity.
This is Mission Control. We've lost signal from the Tracking Data Relay Satellite East. We'll have voice contact with the crew over the Yargity station in about 10 minutes. Just as we went LOS, the crew sent down another little short burst of music. The music seemed to be, from the few bars we heard, the song Hungry Eyes. Here in Mission Control, the Flight Activities Officer and his backroom support team are working to reschedule look at the impacts to rescheduling TV events over the next 3 flight days. Due to the problem with the Tracking Data Relay satellite antenna, the KU band antenna, it is likely that if we can get that antenna into a stowed position and get the pins locked into it to hold it down, it will not be used for the rest of the mission. The antenna, when we looked at it earlier with the TV cameras, seemed to move responding to commands, but would not go back into the fully stowed position. Although the failure mode specifically is not understood yet, the communications officer and his backroom people are evaluating the situation with the antenna. An antenna is available in one of the buildings here at the Johnson Space Center, and some folks from the mission evaluation room and the offgoing communications officer and other technical engineering support are going to set that up and simulate moving it in to the degree that it was able to be moved earlier when Dave Hilmers tried to slew it over to the stowed position. And here on the ground, they'll check and see if that is far enough in for the pins to lock in place to hold it down. And we'll await word from the communications officer of that activity as it continues through the afternoon. Pinky Nelson is working today on the various mid-deck experiments carried aboard Discovery, and he has a task coming up to checking on the PV toss, and he has already activated several of the other, including the aggregation of red blood cells, so that one was deactivated earlier today. The environmental systems engineer, the ECOM, and his back room are continuing to study the problem with the flash evaporator system. It is slowly thawing, we hope, using the radiators at a little higher temperature than normal to try to thaw that out, but it's a slow process, and we'll be getting further information on that as the workday moves along. This is Mission Control.
Discovery Houston with you through Yargity for 5.5 minutes.
Afternoon, Houston.
This is Mission Control. We will be beginning momentarily our change of shift briefing with off-going Orbit 1 Flight Director Milt Heflin. That originates from the Teague Auditorium at the Johnson Space Center. That briefing will begin in just a few moments. This is Mission Control.
Discovery Houston, 1 minute to Yargity, LOS, Guam next at 2:52.
Okay, we'll see you there.
This is Mission Control. We're 1 minute to AOS Guam.
Discovery Houston with you through Guam for 8 minutes.
Okay. All's going well on board. How's everything down in Houston?
It's going pretty good, Rick. We're spending a lot of time discussing KU and FES, and hopefully by the end of the day we'll have some actions for you. Discovery Houston, 1 minute to Guam, LOS, Hawaii at 3:06.
Okay.
This is Mission Control. We're LOS Guam, and we'll come up on Hawaii for communication with the crew in about 5 minutes.
Discovery Houston through Hawaii for 8 minutes.
Loud and clear.
Discovery Houston, 30 seconds till Hawaii, LOS, should be on TDRS within 2 minutes.
This is Mission Control. We'll have acquisition of signal through the tracking data relay satellite in just a couple of minutes. Aboard Discovery right now, the cabin temperature is 84.6 degrees Fahrenheit, and the humidity is about 50%. The crew reports that they've been perfectly comfortable with that temperature, although it is a couple of degrees higher than the average temperature. It's fairly quiet in the Mission Control Center right now. Flight controllers are monitoring their systems. The ECOM officer, consumables and environmental systems.
Houston now on TDRS East.
Loud and clear.
Crew has been fairly quiet the last couple of ground station passes, and they've completed their mealtime now and are doing some regularly scheduled daily housekeeping chores aboard Discovery. This is Mission Control.
Discovery Houston, we'd like to do a UHF radio check through Salinas Peak. If you could select UHF, please.
Volta.
Discovery Houston, UHF only through Salinas Peak. How do you read?
Houston Discovery coming back to air to ground 1 and UHF.
Say again, Discovery?
This is Mission Control. The Capcom call to the crew on UHF.
Discovery Houston, radio check, UHF only through Salinas Peak. How do you read?
Houston Discovery, how do you read?
Loud and clear, Discovery. How us?
Okay, you want me to select air to ground only? I'm sorry, air to air only and turn off air to ground 1 and 2?
Did you have UHF selected? We made a couple of calls here. Did you hear any of those?
Negative.
Okay, we tried a couple of different radios out there, and it didn't seem like any of them worked, so we're going to drop the continuation of that check and talk to you through TDRS.
Okay.
This is Mission Control. Due to no response, the first couple of calls from the Capcom on a UHF radio check, they've dropped that test for the time being, and we'll communicate with the crew through the TDRS. This is Mission Control. At mission elapsed time 1 day, 3 hours and 45 minutes. It remains fairly quiet in the Mission Control Center right now. The INCO communications officer continues to look at the KU band problem we've had. He hopes to have some information for the flight director within the next couple of hours. We have folks here at the Johnson Space Center setting up a simulation of that hardware to see if we drive it in, slew that antenna in to the stowed position, if it'll be close enough in to drive the pins into the slot so that it can be permanently stowed for the rest of the mission. He's also looking at the failure signature and analyzing some data, seeing if perhaps good news might be that perhaps that was a transient problem and could be recovered. So he is analyzing the whole situation very carefully and thoroughly, and his backroom folks are busily working on that. Crew continues through the timeline, and on schedule. And we have about 20 minutes remaining in this TDRS pass. This is Mission Control.
Discovery Houston with some words on FES status.
Go ahead.
Okay, Rick, we in the technical community have been looking at the data for over a day now, and we believe that the Pri-A controller with a topper is okay. We do not want to operate both the high load and topper on the A controller. This is the configuration we had during ascent, and we can't be sure if it's a hardware problem or a nozzle, so we need to disable the high load. We also don't want you to use the Pri-B controller. Looking at data post-ascent had some unexplained, the temperature that controlled at, we could not explain why it was at the value that it was, and we do not have a lot of confidence in the B control at this time, and we're still evaluating. For the high load, we want to keep operating at the high set point for at least 48 hours to make sure the core is thawed out. And we're not sure right now whether we're going to test tomorrow or during deorbit prep. So at this time, we're ready to try the Pri-A controller with the topper. So you can take the flash evap controller Pri-A on, and we're going to bring down the supply water tanks. So we want to dump tank B down to 15%. When it gets to 15%, we'll go ahead and turn Pri-A off.
Okay, the one switch configuration you want is Pri-A to ON, correct?
That's correct.
Okay, here it comes. Blaine, you were aware that on ascent that after the Pri-A ceased to control, that excuse me, Mark, that I cycled over to B, and I'm sure you saw from the playback or even real-time data that it made a valiant effort, obviously, without the high load, but would get down to about 39. I didn't happen to notice a difference in the characteristics when I was on B or A, but certainly you have more data than I did.
Yeah, we saw that, Rick, and the difference is very slight, and we're still trying to evaluate what it means. You'd have to be looking at a strip chart to understand what we're talking about.
I figured. I think I'll pass on that today.
This is Mission Control. Hauk has turned on the switch for the flash evaporator system A. The ECOM officer here on the ground reports that they see data that indicates that is on. The flash evaporator system A is on and operating. The high load is off. This is one of the brief tests to see how that flash evaporator system is coming along. And we'll be watching the data and see what that tells us for the status of that flash evaporator system. We have 12 and a half minutes remaining in this TDRS pass. Mission elapsed time 1 day and 3 hours, 55 minutes. This is Mission Control.
Discovery Houston, we are 2 minutes till TDRS East LOS, Guam at 4:28.
Goodbye.
This is Mission Control. The Environmental Systems Officer, the ECOM, has reported that the test the crew just did on the primary A switch on the flash evaporator A, which tested the topping evaporator, a flash evaporator system, showed that that part of the system works. The topping evaporator is healthy and was working normally and at normal temperatures. Previously, they had observed low temperatures on the ducts of that topping evaporator system at about the same time as the freeze-up of the high-load flash evaporator system. The high-load flash evaporator system is still in the process of thawing out, and we're still watching that. It will be a lengthy, slow thaw-out process. However, they are pleased, flight director and the Ecom flight controller are very pleased to hear that the topping evaporator A is working properly. We will acquire signal again with the crew in about 15 minutes over the Guam station. INCO officer here in Mission Control is still working on the KU band antenna problem, checking out possible causes of that failure. It's not completely understood yet, and the tentative plan is still remains to stow that antenna if we're able to move it over into the stow position and get the pins locked in. However, no firm plans have been announced yet. They're still evaluating other options and other things that might be done to try to recover the system. This is Mission Control. This is Mission Control. We're about 4 minutes from AOS at the Guam ground station. Following LOS at Guam, we'll have a few minutes without communication with the crew. When we come back over the Hawaii station at mission elapsed time, 1 day, 4 hours and 42 minutes, about 3:20 p.m. Central Time, we expect to have downlink TV live from the shuttle. Should be mid-deck views. And once again, that television is scheduled for 3:20 p.m. Central Time over the Hawaii ground station. This is Mission Control.
Discovery Houston through Guam for 9 minutes.
Loud clear.
Discovery Houston.
Roger.
Yeah, Rick, I'd just like to talk a little bit about the FES and how that's going to work the rest of the day and tonight. And now that we have it working, we're going to use that to take tank B down to 15%, so there will be no supply water dump tonight. We do not have enough water to run it all night, so we're going to be turning it off before you go to bed. And what we need to find out was whether or not the cabin was too warm last night, and whether or not we need to pursue a short list of power down options, or if you were comfortable, and this is your call, and I guess you can take some time to think it over and let us know end of this pass or Hawaii sometime.
Okay, I think last night it was okay. One difference tonight from last night is ADSS stays on all night, and that's fairly warm, so I guess I'd be interested in what the proposals would be for the limited power down in case we found ourselves getting too warm over the night.
Okay, Rick, our leading candidate right now is Eclipse SSR-6, if you want to take a look at that.
My gosh, we're going to have to take out the mailbook, okay? Do you think this is a simulation? Okay, Mark, we've looked at SSR-6, and we see the additional items that we would power off. To be more specific, last night, in fact, both Covey and I were a little chilly in our shorts last night, overnight, so I suspect that SSR-6, if we needed to invoke it, we could do that, but right now I suspect we can keep the configuration as is.
Okay, Rick, it's pretty much your call. If you want to keep it as is, that's agreeable with us.
Was your proposal that we do SSR-6 now if we felt we would need to cool off the cabin?
Well, not at this time. Later today, when we go off the FES, we'd propose doing it over, for instance, overnight. But that's pretty much your call, as we said.
Okay, good enough. And we're getting a little pre-cooling from best work. We're in good shape. Thanks.
And we're coming up on LOS. We'll be talking to you at Hawaii at 4:43.
See you there.
This is Mission Control. We're 1 minute to AOS at Hawaii, and we're expecting downlink TV there at the Hawaii ground site. From the crew, it'll be mid-deck views of the crew doing some of the mid-deck payload activities. The SSR-6 that the Capcom referred to a few minutes ago is an in-flight malfunction procedure in the malfunction book that has to do with powering down some of the systems in the crew cabin, and the crew, if they choose before they go to sleep, can do that. That power down would reduce the heat from electronics equipment and could help reduce the cabin temperature. The crew reports that they were comfortable last night and that they don't think that'll be a problem. However, it's their call if they use that procedure. Temperature in the cabin currently is 82.4 degrees Fahrenheit with a humidity of 33%. And we'll be looking for our TV here in just a few moments. This is Mission Control.
Discovery Houston through Hawaii for 8 minutes.
Howdy, Houston.
This is Mission Control. Unfortunately, our television on this Hawaii pass has been canceled at the last minute. We don't know exactly what happened, but the TV was unable to get downlinked, so we'll try again on orbit 21. For the present time, that Hawaii TV has been canceled. This is Mission Control.
Discovery Houston now on TDRS East.
We're still on Discovery.
This is Mission Control at Mission Elapsed Time 1 day, 4 hours, and 56 minutes. We're on the descending node of orbit 20. Crew of Discovery has about 4 hours remaining in its second work day on orbit. Flight control team received a weather briefing a few minutes ago for the landing weather at all landing sites on Saturday, Sunday, and Monday. And they're all looking quite good. Good weather forecast for all 3 days for landing at Edwards. Although landing is planned for Monday, the flight control team likes to keep up with the weather, stay current on it in case there happens to be a need to come home any earlier. And a weather briefing is a standard part of every shift in the mission control room. Communications officer is continuing to evaluate the KU band antenna to determine if we can try to move it over into the stow position and lock the pins in place. We have not heard back yet from engineers here at JSC who are trying to simulate that activity in another building. The engineers were intending to using some antenna hardware, try to drive it into the same parameters where we were able to get it earlier today, several hours ago, and see if we could lock the pins in place with it at that location. One of the experiments that has been in operation today on flight day 2, one of the mid-deck experiments, is the isoelectric focusing experiment. Principal investigator is Bob Snyder of the Space Science Laboratory at the Marshall Space Flight Center in Huntsville, Alabama. This is a type of electrophoresis experiment which separates proteins in an electrical field according to their surface electrical charge. It is hoped that the results of this investigation will enable researchers to develop a process for large-scale purification of proteins. This experiment resides in the mid-deck in one standard locker space, and it's battery-powered. That was activated earlier today by Pinky Nelson. This is Mission Control. This is Mission Control at mission elapsed time 1 day, 5 hours, 19 minutes. We have about 25 minutes remaining in this TDRS pass. One of the activities coming up in about 45 minutes at about 6 hours mission elapsed time on day 1 is the a photo session with the protein crystal growth experiment. This experiment is carried in the mid-deck locker. It weighs in one locker space. It carries numerous kinds of protein fluids that will be used to grow some protein crystals. One of the reasons for doing this kind of research in the microgravity environment of space is that protein crystals grown on Earth are often small and flawed. And on 4 previous shuttle missions, the protein crystals grown there have shown evidence that superior crystals can be obtained in the microgravity environment. Principal investigator for the protein crystal growth experiment is Larry DeLucas of the University of Alabama at Birmingham. All of these crystal samples, protein crystals, will be returned to the principal investigator immediately following the end of the mission, and they will be used to attempt to develop pharmaceuticals, perhaps. There may be advantages of using these protein crystals and understanding the precise structure of these molecules can help scientists to understand the biological function that these proteins have. Communications officer is still working on the problem of the KU band antenna. The tentative plan at this time remains to stow the antenna if we're able to get it in that position and get the pins locked in place. This is Mission Control.
Discovery, Houston.
Roger.
Roger, I've got 3 flight notes here for you from ECOM for some pre-sleep water dumps and other activities whenever you're ready to copy.
Okay, be a minute or two.
Discovery, Houston, did you call?
Negative, but we can take your flight notes now.
Okay. We would like you to dump the wastewater tank per the procedures on page 5-6 of the Orbit Ops checklist down to 20% this evening. And we want you to dump the wastewater first, and then after you've done that, we want you to do a supply water dump per page 5-2 of the Orbit Ops checklist, and we want you to dump tank Bravo to 30%. Just a note to make sure that the supply water crossover valve is closed per the procedure before beginning the dump, because as you know, we have that open right now. Tonight, you don't have to deconflict the dumps with the IMU Align, since the Align will be in darkness tonight. Also, for your pre-sleep cryo configuration, on R1A2, we want cryo O2 H2 tank 3, heaters A and B to auto, cryo O2 H2 tank 1, heaters A and B to off, and cryo O2 H2 manifold valve tank 2, both valves, to closed. And of course, you will get the usual Spec 68 message when you close those manifold valves.
Okay, say again the wastewater dump quantity.
Wastewater dump, we want that dumped to 20%, 20.
Okay, waste to 20, then the supply Bravo to 30% with the crossover closed. It's okay to dump during the IMU Align. We'll take the tank 3 heaters, all four of them to auto, the tank one's OFF, and the O2 and H2 manifold valves number 2 to close. Two of them, correction, two of them.
That's right. It's tank 2, and there are two manifold valves. That's correct.
Okay.
Okay, that's good. And we'll have a few more pre-sleep tag-up words for you in a few minutes.
Very good.
This is Mission Control. The flight control team is gathering up its pre-sleep tag-up messages to pass along to the crew so that they can have all the switches and housekeeping chores completed before their pre-sleep period. Their sleep officially begins about 6:37 this evening Central Daylight Time, about 2.5 hours from now.
And Lacey, how do you read the IRCFE through the South Atlantic anomaly?
Pinky, we read you 5 squared.
Okay, it seems to be performing about the same as before. I don't notice any difference at all. I wouldn't have expected much.
No, you sounds essentially the same as you have on the other calls on IRCFE.
Okay, and I'm going to go ahead and start up ADSF and PV-TOS, if that's okay.
Okay, we'll check real quickly and call you back.
Okay.
Discovery, Houston for Pinky.
Go ahead.
Roger, Pinky, we'd like you to wait until after the IMU align to activate ADSF and PV-TOS.
Okay, I'll do that.
Okay, thanks. This is Mission Control. The IRCFE experiment that Pinky Nelson was trying out with Capcom Lacey Veach a few minutes ago is the Infrared Communications Flight Experiment. It was designed and developed at the Johnson Space Center, and the principal investigator is Joseph Prather of the Engineering Directorate's Tracking and Communications Division here at JSC. The experiment has Nelson using infrared light waves that the same kind that control remote controls on TV sets and VCRs here on Earth. This experiment will provide information about use of infrared light as a voice and information carrier. Could have widespread future applications for the shuttle, Space Lab, and the space station, as well as other non-NASA uses such as military aircraft, naval vessels, and Army combat vehicles. At mission elapsed time, 2 days, 5 hours, and 35 minutes. This is Mission Control.
Houston Discovery, let's do another voice check on the IRCFE here in the middle of the Atlantic.
Okay, Pinky, we read you the same, loud and clear.
Okay, you're the same. I don't notice any difference at all. If that's satisfies you, I'll put it away. Otherwise, we can wait, I guess, till the next rev.
Pinky, go ahead and put it away. I think that we've gotten as much good data there as we're going to get.
Okay, thanks. I'll do that.
Discovery, Houston, we're going to hand down to iOS in about a minute and a half.
Okay, roger that.
Discovery, Houston, we're talking to you through Indy now for the next 8 minutes.
Roger, Houston, and I've got the IMU align log if y'all needed numbers.
Dick, we don't need it. Thanks, though.
Okay.
This is Mission Control. The tone on the air ground is most likely, the communications officer advises, most likely the crew aboard Discovery advancing the paper. advancing the paper in their teleprinter. Nothing is being uplinked from Mission Control.
Discovery Houston, we're 1 minute to iOS LOS, and we'll see you next at Guam at 6:20.
Okay, I see that.
This is Mission Control. We've lost contact through the Indian Ocean Station, and we'll have acquisition through Guam in 16 minutes. During this last stateside pass and over the the South Atlantic Ocean, Nelson made 2 more attempts on the IRCFE experiment, the one that tests voice communications using infrared light waves. Also, Pinky asked to start or activate the ADSF and PV-TOS experiments, and was requested by payloads folks to hold the activation time on those 2 experiments until after the IMU alignment in order to align those that inertial measurement system. The orbiter has to make a small maneuver, and both the PV-TOS and ADSF experiments are sensitive and need as much quiescent attitude as possible, so he held off on starting those up until after the IMU aligns. Flight controllers here in the Mission Control Center are wrapping up the crew's workday, gathering items for the pre-sleep tag-up. We're about 2 hours away from the crew's official sleep time, which will be about 6:37 p.m. Central Time. The flight controls team has already given the crew a few of the flight notes, switch configurations and so on, water dumps, supply and wastewater dumps to be taken care of before sleep. Flight dynamics officer and the propulsion officers have just given their okay on the trajectory message, message that it goes up every evening before the crew sleep period begins. Mission elapsed time 2 days, 6 hours and 5 minutes. This is Mission Control.
Discovery Houston, we're with you through Guam now for 6 minutes.
Roger. Houston, Discovery.
Go ahead, Discovery.
Roger, we have on board message 19. We do not have 16, 17, or 18. Would you verify that that's correct?
That is correct, Rick, and we'll talk to you at Hawaii in about 6.5 minutes.
Stay there.
This is Mission Control. We're going LOS in Guam. That very short pass will be coming up on Hawaii in 6 minutes. Flight controllers are gathering up their final tag up for pre-sleep with the crew. The flight director plans that this last AOS at Hawaii will probably be the last time we talk to the crew for today's work day on flight day 3. This lets them be free of calls from Houston for a while and have a little bit of extra free time in their pre-sleep period. Messages that Hauk was referring to are the teleprinter messages sent up at the end of every workday. The regular, ordinary crew tag-up items, trajectory messages, switch alignments, and so on. Those messages are sent up on the teleprinter. This is Mission Control.
Discovery Houston, we're talking to you through Hawaii for the next 8 minutes.
Roger, we copy. Houston, Discovery, I don't know if y'all are prepared to take any, but if you'd like, you can take Payload Bay TV. We'll downlink it to you.
Okay, thanks, Dick. We're doing some recorder dumps right now, so I guess we're going to press on with that. Discovery, Houston.
Go ahead.
We've decided we'd like to get some TV downlink after all.
Okay, it's coming to you.
Hawaii no Ka'oi, Discovery.
Yeah, us too.
This is Mission Control. We're getting lovely Earth view photography of the Hawaii and Emperor Island chain from the payload bay of Discovery. These islands were formed hundreds of thousands of years ago by ancient extinct volcanoes, and they reside on the Pacific tectonic plate.
Discovery, Houston, that's a beautiful view of the big island there. All of us here in Mission Control have surely been enjoying the Kona coffee sent to us courtesy of the Onizuka family.
Well, that's great, and we've been enjoying a little bit of that up here on orbit also.
Yeah, ono da kaina. Discovery, we have 1 minute to Hawaii LOS, and we'll be with you through TDRS after a short dropout.
Roger.
This is Mission Control. We're LOS from Hawaii, and we'll hand over to TDRS for voice tag-ups with the crew in a couple of minutes. This is Mission Control.
Discovery, we're with you through TDRS now.
Roger, Houston, you're loud and clear.
This is Mission Control. This is a replay of our television that came down a few minutes ago from the Hawaii Pass. Earth views of the Hawaii and Emperor Island chain in the Pacific Ocean, shown from the Payload Bay TV cameras of Discovery. This is Mission Control.
Discovery, Houston.
Go ahead.
Roger, we're ready to do a pre-sleep tag-up with you whenever you are. Give us a call.
Okay, stand by a second. We're ready.
Okay, Rick, we don't have a whole lot for you tonight. From Pinky, we would like to get the ADSF and the PV toss initiate times, and would also like to know if he has been able to see any crystals forming in PCG.
Well, I can give you that right now, Lacey.
Okay, go ahead.
Okay, PV toss first. Cell 3 was initiated at 2 days, 6 hours, and 9 minutes, and no anomalies on that one. ADSF was initiated 2 days, 6 hours, 30 minutes, and it seems to be working well. As far as protein crystal growth, Mike and I just finished the photo session of that a few minutes ago, and we noticed lots and lots of crystals. Next time we look at it, we'll make a list of which cells are, and I think it's safe to say there were crystals in all of them. So.
Okay, we copy that. That's good news. Tomorrow's timeline will be a nominal cap, except adjusted as for TV over the Staten sites as we did today. And we'd like any feedback that you might have for FAO on anything that you saw in the deorbit prep rehearsal that you might want to suggest for adjusting the deorbit timeline.
Hey, we sure appreciate the question, but I think the timeline should work as is long as we have a nominal deorbit prep.
Okay, thanks a lot, Rick. Mike Coates and a crew will be in the SMS tomorrow, and they're going to do some runs to verify FES configs for you for entry.
Okay, thanks.
And Discovery, from everybody here in Mission Control, we all want to thank you for your good words about the Mission Operations Directorate. That was very much appreciated by everybody here in this room and all the back rooms around here.
Well, it's sure a team effort, and heavens knows that NASA and the contractors have shown how teams can work together.
You're right about that. Oh, we have just one more thing. That's it, but we've got one more thing for Pinky. There are 2 minutes left in the game, and Washington and UCLA are tied 17-17 with 2 minutes to go. We know you want to get on.
Dogs.
Raj, we know you want to get on to bed, so we won't bother you anymore, and we'll pass up the final score in the morning.
Okay, thanks. Lacey, on your morning message, I presume you'll give us a summary of where you think we are on the FES.
That's correct.
Okay. And Houston, it's hard to acknowledge people without leaving some folks out, but we need to acknowledge quite a few other folks. We've talked about the Cape getting us into the air. Of course, that was the processing. Folks at Marshall, not only from the SRB and the main engine side, but from the payload support side, have sure done superbly, and we appreciate all that folks at Goddard have done, keeping us in communications and so forth. And all of the communication support tracking support we get from the Air Force and so on, it's just really superb.
Rick, thank you very much. We'll make sure that we pass that word along. And PO would like to thank you very much for all those beautiful views of the planet Earth that you gave us, and also for but most of all for the tour of...
Okay, you dropped out the very last
Raj.
sentence.
Well, we wanted to thank you for all the great views of the world that you gave us today, but I think most interesting was the tour of Covey's pockets.
Well, I didn't let him show you everything he had in there. And Houston, would you pass on to PAO that we're still planning on the starting off the crew conference the way we had discussed pre-flight?
Roger, Rick, we understand that.
Okay. Now, of course, because of our limited coverage, due to no KU band, if you'd prefer that we do that on a different rev, we certainly could accommodate that.
Okay, we understand that. I think for now we can go with the plan as is. Whatever we do, we'll be sure to give you the time that you need.
Okay, plan on about 3 minutes.
Okay, we copy that. Discovery, Houston.
Go ahead, Houston.
Roger, I can give you a quick recap on where we think we stand with the FES right now, if you'd like that. And then we'll call it a night.
Stand by.
Okay.
Houston Discovery, we're ready for the FES status report.
Okay. After looking at the topper over the past 2 days, we're sure that the topper is in good shape on all the controllers. And we believe that all the ducts on both the topper and the high load are clear at this point. We plan on staying at the high set point on the Freon loops, until we do the rad bypass and FEST checkout and the deorbit procedures. And we intend to move that earlier by about 30 minutes from its nominal point of 250 in the deorbit timeline to about 3 hours and 20 minutes in the deorbit prep timeline. And we are pretty sure that when we start up the high load that it will work fine. That's our judgment at this time. We do think that the high load will probably work better using the B nozzles, the Bravo nozzles, and we will incorporate that into our deorbit procedures. And that's about it. Do you have any questions on that for us?
Houston, no questions. Sounds pretty good to us. Could have been a lot worse.
Roger that. Well, that's all we have for you. We'll give you one last LOS call at TDRS LOS, and then not talk to you again tonight.
Okay.
This is Mission Control. The Capcom Lacey Beach ran through the last-minute tag-ups pre-sleep with the crew, including some information about the flash evaporator system status and the plans for Flight Day 4 and the preliminary plans for deorbit. Hauk thanked the support team of NASA personnel and contractor personnel at KSC, Marshall Space Flight Center, the Goddard Space Flight Center, and the Air Force Communications Network. And we'll be giving the crew one final last LOS call at LOS TDRS about 21 minutes from now. This is Mission Control. This is Mission Control. The flag we see in Mission Control is the Delta Team INCO flag in celebration of STS-26. The INCO for Orbit 2 team, John Muratori, is having his last mission as an INCO. He'll be moving to promotion position on the division staff of his organization. John and his backroom team did a really fine job yesterday and received compliments from the flight director in coming up with the procedure to stow and secure the KU band antenna. So John brought his INCO team flag into the mission control room today in observation of his last flight supporting a mission as an integrated communications officer. This is Mission Control.
Discovery Houston, we'd like you to go ahead and terminate the B-tank supply water dump now.
Okay.
Discovery Houston, we're heading down to Indy.
Okay.
Discovery Houston, we're 1 minute to IOS LOS. We want you to check your RJDs and your cameras off before you go to bed tonight, and this will be the last time that we talk to you this evening. We sure enjoyed working with you today. We look forward to seeing you one more time tomorrow.
Good night, Houston.
Good night. Discovery Houston, one last call for Pinky. The final score of the game was 24-17, and the winner of the game was
all right.
This is Mission Control. We've lost communications with the crew on the at the Indian Ocean Station, and one last little dig at Pinky Nelson from Capcom Lacey Beach was to give him the final score of the UCLA Washington game and garble who the winner was. So now Pinky Nelson will have to wait till the morning teleprinter message to find out who the winner of the game is. We have bade the crew good night, and they answered with a good night, Houston. This is Mission Control. This is Mission Control. At 7 p.m. Central Daylight Time, about 30 minutes from now, we'll have a replay of all of the shuttle TV, Flight Day 3, including mid-deck and flight deck activities and Earth views. The replay will begin at 7 p.m. Central Time and is 1 hour and 30 minutes long, so it will last until 8:30 p.m. Central Time. This is Mission Control. This is Mission Control. Discovery is now passing over the Hawaii ground station on the descending node of orbit 38. The crew is officially in its sleep period. However, not very likely that they're really asleep right now. Flight control team is working on the end of mission messages and the messages that will go up to the crew tomorrow morning. Orbit 2 team wrapping up the final details of its work day. We will be expecting the Orbit 3 or planning shift team to be arriving in Mission Control about 7:30 this evening for their handover briefing. And they will assume control of the flight at 8:30 p.m. At 7 p.m. Central Time, we have a replay of all of the TV activities from Flight Day 3. That's an hour and 30-minute replay of all the TV downlinks from today. It begins at 7:30 p.m. Central on NASA Select. This is Mission Control. This is Mission Control. Discovery is now passing over South America. Crew is asleep. In the flight control room, the planning team members are beginning to arrive, one or two at a time, and beginning the preliminary handover from the Orbit 2 team. It's fairly quiet. No big systems problems aboard Discovery. We're expecting Flight Day 4 to be pretty much as scheduled. At mission lapse time, 2 days, 8 hours and 44 minutes. This is Mission Control. This is Mission Control at mission lapse time, 2 days, 9 hours and 14 minutes. Discovery is just coming up the top of the ascending node of orbit 39, just going out of TDRS range for data downlink from Discovery. Mission controllers are continuing their handover here from Orbit 2 to the planning team. Quite a bit of activity in the flight control room right now. Discovery's workday will start about 6 hours and 45 minutes from now, about 3:30 in the morning, Central Time. This is Mission Control. This is Mission Control at mission elapsed time 2 days, 9 hours and 50 minutes. Please note that we are going to advance the time of the change of shift briefing with off-going Flight Director Chuck Shaw. We're going to move it up 15 minutes to 9 p.m. Central Time. Once again, that change of shift briefing with Orbit 2 Flight Director Chuck Shaw will begin at 9 p.m. Central Time instead of 9:15. The beginning time of the press conference is at 9 p.m. Central Time. This is Mission Control. Our change of shift briefing with Orbit 2 Flight Director Chuck Shaw is scheduled now for 9 p.m. Central Time, originating from the Teague Auditorium at the Johnson Space Center. The new time for this briefing is 9 p.m. Central Time, 15 minutes earlier than previously scheduled. Please note the new time of 9 p.m. This is Mission Control.
This is Mission Control. The handover to the planning team is now complete. Larry Bourgeois, lead flight director, is now on console, along with Capcom Kathy Sullivan and Pierre Thuet. We're getting ready to have a change of shift briefing momentarily in the Teague Auditorium. This is Mission Control, 2 days, 10 hours into the flight. This is Mission Control. We will have a change of shift briefing with off-going flight director Chuck Shaw at 9 p.m. Central Daylight Time in Teague Auditorium. That's a change of shift briefing with off-going flight director Chuck Shaw at 9 p.m. Central in the Teague Auditorium. This is Mission Control. This is Mission Control Houston. Tonight when we were handing over from the Orbit 2 team to the planning team, no new problems were reported. Everything seemed to go smoothly today. Payloads reported that they have good TDRS communications. They're very happy with the various mid-deck experiments and how they're going. The protein crystal growth is going well, and the astronauts reported that they saw crystals in the chambers, which made the principal investigators anxious to get those containers back so they can take a look also. Tonight we're going to be working on re-entry procedures, discussing the various options, and have them ready for the re-entry team to evaluate when they come on their shift in the morning. Today we got to see television of Pinky Nelson on the middeck and Rick Halk on the flight deck donning the new launch and entry suits, the partial pressure suits, and they were practicing for tomorrow to see how much time to allot in their deorbit prep the morning of re-entry. We also saw Pinky Nelson unstowing the pole. We expect it to be fairly quiet here in Mission Control this evening, since we have no systems problems to be working on except the flash evaporator system, which is continuing. This is Mission Control, 2 days, 10 hours, 33 minutes. This is Mission Control. Discovery is now on orbit 40 on the ascending node over east coast of Africa, the bottom end of Saudi Arabia. The crew is a little over 5 hours into their sleep, or have about 5 hours rather until they wake up in the morning. They're about 3 hours into their sleep period. Tomorrow they will be having a crew press conference on orbit 49 at approximately 11 o'clock Central Time. This is Mission Control, 2 days, 10 hours, 46 minutes into the flight. This is Mission Control. Discovery is currently over the Guam ground station and on orbit 40. The crew has almost 5 more hours in their sleep period. Tomorrow they will be having a crew on-orbit press conference. It's rather quiet this evening here in Mission Control as the flight control team is looking over notes to send up to the crew by teleprinter in the morning. They are looking at deorbit preparations in preparation for re-entry on Monday morning. Re-entry will occur, or rather landing will occur at Edwards at approximately 11:37 a.m. Central Time if we have our nominal landing as planned. on orbit 64. This is Mission Control. 2 days, 11 hours, 11 minutes into the flight. This is Mission Control. We have just acquired Discovery through TDRS East, and we are now having a weather briefing of the next few days here in Mission Control at the present time. When weather looks good for landing at Edwards Monday. This is Mission Control, 2 days, 11 hours, 35 minutes. This is Mission Control Houston. It's very quiet this evening in Mission Control. As I said earlier, during a planning team handover from the Orbit 2 team, there were no new problems reported. Today's activities included trying on the new launch and entry suits on orbit, because that has not been done before, to see how much time it would take for deorbit preparations. It did take a little while, and we got to see video of Commander Rick Halk and Dr. George Pinky Nelson slipping into the suits. We also saw television of unstowing the new telescoping pole to be put in place. Pinky Nelson did that as a practice to see how long that would take also. This is Mission Control at 2 days, 12 hours, 7 minutes. This is Mission Control. We have a White Sands progress report on the Tracking and Data Relay Satellite, TDRS-C. Controllers at White Sands, New Mexico, plan to start drifting TDRS-C to a 150-degree west longitude position Sunday. Moving the satellite, which was deployed from Discovery Thursday, was delayed one day when a fuel valve apparently closed, cutting off fuel to the spacecraft's thrusters. Investigation indicated the valve may have closed as a safety measure when control of the spacecraft was being transferred from one control center at White Sands to another. Tests of the system following the failure were successful. White Sands also reported that one of the single-access antennas had a delayed deployment during the process of unfurling solar panels and other appendages. The satellite's tiny thrusters will be fired for 21 minutes Sunday. The drift to 150 degrees will take 12 days. This is Mission Control, 2 days, 12 hours, 29 minutes. This is Mission Control. The planning team is looking at re-entry procedures, discussing various options for the re-entry team to evaluate when they take over their shift in the morning. Otherwise, it's very quiet this evening. There are no new problems to report. Everything's fine. The crew has 3 more hours in their sleep period. This Mission Control, 2 days, 12 hours, 54 minutes into the flight. This is Mission Control. The planning team is now checking messages before they get finalized to send up to the crew by teleprinter in the morning after they awake. They will be waking up in about 2.5 hours. Today's activities included completion of the LRAD experiment. The 2 student experiments went well, and we got to see them on television earlier today. The protein crystal growth experiment is going well. There are crystals in the chambers. This is Mission Control, 2 days, 13 hours, 31 minutes into the flight. This is Mission Control. White Sands told us that tomorrow they plan to start drifting Tracking and Data Relay Satellite C, which was launched on Thursday from the payload bay of the Discovery orbiter. And they are going to drift it to 150-degree west longitude Sunday, and it will be in geosynchronous orbit in about 12 days. This is Mission Control, 2 days, 14 hours, 3 minutes. This is Mission Control. Orbiter Discovery is now on the descending node of orbit 42. Here in Mission Control, it's very quiet this evening as the flight control team reviews messages that will be sent to the crew by teleprinter tomorrow morning after they awake. They will be waking up in about an hour and a half from now. This is Mission Control, 2 days, 14 hours, 27 minutes. This is Mission Control. The STS-26 crew has about another hour in their sleep period. When they wake up, of course, they'll exercise a while and have some breakfast before starting their daily routine, which includes some more mid-deck experiments and then a press conference midday, about just before 11 o'clock Central. And later in the day, they will start their deorbit preparation for landing Monday at Edwards. This is Mission Control, 2 days, 14 hours, 58 minutes. This is Mission Control. The Discovery crew will be awake in a little over 30 minutes to begin their fourth flight day. And during this day, they'll be doing some more mid-deck experiments. They will have a crew press conference at about 11 o'clock Central. They will begin deorbit preps in preparation for landing on Flight Day 5 at Edwards. The weather is looking good for that landing. This is Mission Control, 2 days, 15 hours, 27 minutes. This is Mission Control. Discovery's now on orbit 43 on a descending node. They will receive acquisition with TDRS in 27 minutes. The crew should be waking up in about 5 minutes, but we will not have contact with them until we reach TDRS. This Mission Control, 2 days, 15 hours, 55 minutes. This is Mission Control. We'll reach TDRS coverage in about 10 minutes, and a teleprinter message will be sent to the crew with their updated crew activity plan for today. They will be exercising and having breakfast, activating some more of the mid-deck experiments, and then there will be a crew press conference at about 11 a.m. Central Time in the morning. And then they will begin their deorbit preps by stowing the cabin, getting ready to return home on Monday morning. This is Mission Control, 2 days, 16 hours, 13 minutes.
Hi, Pinky. It's me, Robin. I went to Claremont Men's College while you were going to Harvey Mudd. Hey, here's a song going out to all those Pitzer girls.
Harvey Mudd, Harvey Mudd, Harvey Mudd, Harvey Mudd. Forever let us hold our signals high, 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 high. Calculus and Newton's law and relativity. H-A-R-V-E-Y and U-double-D. There's a college way up north that's made for you and me. H-A-R-V-E-Y and U-double-D. Harvey Mudd, Harvey Mudd, Harvey Mudd, Harvey Mudd. Forever let us hold our signals high, 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 high. Calculus and Newton's law and relativity. H-A-R.
Are you awake yet?
V-E-Y.
Why? Because it's time to eat breakfast from a toothpaste tube.
M-U-double-D.
Good morning, Houston. There's not a dry eye in the house.
Good morning, Pinky. We knew you would just want to hear that great song from your alma mater.
Been waiting a long time for that one.
So have we, so have we. We have little in the way of immediate traffic for you this morning. We'll start the morning mail up here shortly. For Covey, when you get around to the water dumps, we indicate flashing the water this morning, but it's your option. Whatever you think will give you the most comfortable cabin, we can flash it, or we can dump it and just let us know what you'd like. Other than that, have a good breakfast, and we'll be standing by.
Okay, thanks very much. Looks like a men's locker room up here right now. We're all getting clean, ready to go for the next day.
Well, enjoy your morning, Rick, and we're just standing by for you.
This is Mission Control. The wake-up music you heard this morning is the fight song from Dr. George Pinky Nelson's alma mater, Harvey Mudd. Correction. The song was provided by Mrs. Iris Critchell in the aeronautics program, and it was performed by 8 current undergraduate students at Harvey Mudd. The introduction was again by Robin Williams, who attended Claremont. The response from Pinky Nelson was, "There's not a dry eye in the house." The crew is beginning their daily activities, exercise, breakfast, before getting on with the rest of their routine for the day. This is Mission Control, 2 days, 16 hours, 28 minutes. This is Mission Control. The flight activities officer has just notified flight that the morning mail is now on board the orbiter. Their crew is awake and is beginning their morning exercise, and will be having breakfast soon. This is Mission Control, 2 days, 16 hours, 37 minutes. The entry team, or Orbit 3 team, is beginning to arrive in Mission Control for shift handover and debriefings on what occurred overnight. There were no new problems reported. The planning shift team did look at some options for flushing the ice out of the flash evaporator system for the Orbit 3 team's review and approval. The crew woke up at 3 a.m. to a special fight song from Pinky Nelson's alma mater, Harvey Mudd. The song was provided by Mrs. Iris Critchell in the aeronautics program, and it was performed by 8 current undergraduates at Harvey Mudd. The introduction again was Robin Williams, who attended Claremont. This is Mission Control, 2 days, 16 hours, 48 minutes.
Houston, Discovery.
Discovery Houston, go ahead. Discovery Houston, go ahead.
Yeah, it looks like TV toss cells 3 and 7 had a successful run, and I've got the activation deact times if you want them.
Now we copy Pinky, and we're ready to copy your times.
Okay, cell 3 activation 2 days, 6 hours, 9 minutes. Deact 2 days, 10 hours, 52 minutes. Cell 7 activation 2:10:52. Deactivation 2:15:36.
And we got a good copy, Pinky. Discovery, Houston. Discovery, Houston.
Roger.
Yeah, we may lose you here because you're on the tail. We'll LOS in about 3 minutes, 30 seconds. We'll pick you up at Yargity UHF at 1732.
I think you lost us.
And Discovery Houston in the blind, Yargity UHF at 1732. Discovery Houston, that'll be Yargity UHF at 1732.
We'll be up. We'll be up.
Okay, and we may not have a Canberra pass due to ground station problems.
Discovery Houston through Yargity for 5 minutes.
Okay, that's clear.
And you're loud and clear also.
We got 1 or 2 extra Mexican scrambled eggs and tortillas up here if you want to come on up.
I'd love to.